Questions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.
Hey everybody, I was seeing if I could start right at 8. I was like, can I start right on the dot? It's still 7:59, so very sorry. It says 7:50. It says 8. We're starting right at 8. Wacky Wednesdays. I know, and I realized that as I was starting up, I was getting everything ready. I was talking to everyone in the chat. So hey everybody in the chat. I was getting everything all started. I'm going to move my thing a little bit over here. Every time I bump the camera, I move it a tiny bit. Every time I'm turning it on, I need to... Oops, now I just hit my microphone. I was going to hit the microphone. But every time I move the camera just the tiniest of bits, hopefully I didn't just like hurt the microphone. But let me do that real quick. Let me change the daily event right here. I bet I can change it. Let me go over here because we need some Wacky Wednesdays. We need it. Up. Is this right? Hopefully, okay. Should it work? Yeah, here's some Wacky Wednesdays right here. It is Wacky Wednesdays. You never know what's going to happen with these points, but it is Wacky Wednesdays right here. The one I was like, the one thing I forgot to do was change the daily event. I was like, no, I need to put, I've got multiple things. You can't, wait. There you go. You can see the stream deck right here that I'm using to do every little change when you see me changing things. I've got all my buttons. And so I need to have like every daily event on here, but I've got all the little things. This morning you guys going, oh, you bet, we got that. See, there it is. Like a randomness gesture. You guys can still hear me in the background. Look at this. There we go. Bring it down. Bring it around. Down. There we go. Crab rave to start off the morning. Crab rave to get excited. So the big thing, one, our numbers are still pretty good on watching live, but hopefully they're still good right now. I didn't look, but I look at them yesterday. I look when the stream ends and people come to class and they stay in class. We're having about 75% of the class watching live. So if you're here right now, you are doing the right thing. Two things. One, let's take some notes on likes from Brian, advice from Brian. One, let's bring us down here. So be watching live and be interacting. Be taking notes. Have your pen out beside you. Be taking notes or be writing it down in our studio or R, like right along with what I'm doing. I also post the notes afterwards. Has anyone gone and found, let's head over to the main screen. Let's go to the main screen. Has anybody done this? Let me go over here. And here we go right here. Here's 320. So if you go to 320, you will see where I've been posting the code. Has anybody gone and looked at the code or downloaded it and maybe added their notes or looked through it? Has anyone done that? That's like one of Brian's advice. Like, let's put down some advice for the class. Because I know maybe some people are feeling, oof, this class got hard. Oh, yep, there we go, Jordan. That's why I'm mentioning it. I want people to know that these things exist. So one, download the code Brian wrote and look through it and run it. Ah, Sylvia, that's so awesome. Yeah, that's what I want. That's why I want to post these things. It's all about figuring out this plan for you that works, that just like helps you in the class. And lots of people are emailing me. Keep emailing me. Don't worry. I get a lot of emails, but I like that. And like sometimes it might take me 2-3 hours to respond. Sometimes I might respond in 30 minutes. So hopefully in Control F through the slides. Oh man, let's put that down. That's 20 points right there, Alex. Control F through the slides. Like definitely looking through the slides. They've got tons of examples. Pretty much the whole assignment that's due tonight now. Some people might have turned in last night, got the extra credit, but the whole assignment, it's all written through the slides in somewhere. Like, okay, wait, 150 slides or so, and somewhere in these slides is the answers. But if you go to the section that code is being done, like if it's a witch or something, if you go to that section, you can better figure out like, okay, wait, I have to use this some way. And then if you start to figure it out, it's all about learning. Stevenson, good morning to see you here. 10 points, Stevenson, right there. We're gonna do 60 points today on these Wacky Wednesdays. I can't do Wacky Wednesdays, but I can do a rainbow with you. Imagination. That's the wrong way. Imagination. It's the imagination right there. The effect wasn't completely over my head. One, email Brian when stuck. Wait, but also, here, wait, a few things. when you email me, I almost closed this out this morning. Everyone's doing amazing on the title. Everyone's getting the title down. So thank you. That's so awesome. I really appreciate that. A lot of people are sending me a picture of the problem. When you send a picture of the problem, use snipping tool for the problem or use Command Shift 4. It's way easier to see your screen. It's a smaller file. When you take a picture of your screen with snipping tool or something, and usually probably take your full screen. Like sometimes there's something I need to see in the global environment. But if you go down here and do this and send this picture, this is very easy to read. I can like zoom in on it really well. It's a very common practice. Don't worry if you're the only one, but a lot of people will take a picture with their phone and send it with their phone. Maybe I guess they might send it via their phone. So they might take a picture on their phone and then send it via their phone. But it's oftentimes harder to read. And when you zoom in, it gets very blurry and there's like lines across the screen and it's like sometimes at an angle. So when you do it this way, it's a lot easier to read what's going on. Like this can just be copy pasted into an email. So I could just go here, copy paste into an email, or I could save this file right here. Way easier to see. This is snipping tool on a PC or Command Shift 4 on a Mac. That's the best screenshot to take. But then also, please send me your file. When you run into a problem like it won't knit or it can't find this file or it can't do this, it can be something earlier on. So don't worry if you were one of the many people who didn't send me your file yesterday. I'd say less than 50% of people were sending me their file. So, and then I did try to solve many of them without the file. I'll look and if I can solve it sometimes without the file, I will. But sometimes it can be a lot harder to solve it without the file. And I'll like, wait, I don't know if this problem comes from another spot because you might think that it comes from here, but it comes from earlier on. So always send me the picture of your problem and send me your file. And that way I can be like, okay, let's figure out what's going on right here. And if you send me your file like earlier on, probably you're all right. Like if you're like, hey, now this thing's not working for the file. But if you can just attach the file, it really, 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 really helps. And I'll email you back as soon as I can. And like lots of people, we were working really hard yesterday. I do want to mention Dennis, you in the chat. Dennis, it looked like yesterday was a really good. Oh no, Dennis isn't here. But who was on the Discord yesterday? Was anyone on the Discord helping out and working with each other? Yeah, the picture of the problem. Send me as much as you can of it. Like usually, if you can send a full screenshot like this, that's the best thing. Like if you run into an error, like let's say you put a code here, and your code, like let's say you do something like 0 divided by 0, and you get this error right here. And you're like, I don't know why I got it. Oh, that's so awesome, Dennis and Brad. Wow, rock stars, man. That is awesome. Yeah, no, and the Discord is completely awesome, and it's looking like it's exactly what I want it to be. Oh, that's so weird, Dennis. I was typing to you, and I guess if you're lurking, I couldn't tag you, Dennis. So yeah, I couldn't tag you. I tried to tag Dennis in the chat, and I was like, "Where's Dennis at?" Dennis, thank you again. People, I saw that you guys were meeting after class, and so if you guys want to keep doing that and meet after class, and then come to me with issues, I mean that's awesome. Like, because I teach the next class right after this. So if you guys and gals want to meet on Discord, go through many of the problems. But I love that. I'm so proud of everyone because like I'm tearing up. I'm so proud of you guys. I really am. This is so awesome, and I want people to feel like they have help at every opportunity. And Dennis has helped facilitate that. And thank you, Dennis. Just like everyone, give a big round of applause. Tag Dennis and give him some appreciation for kind of creating something I had thought up that we should do. I literally just mentioned it, and Dennis is like, "Oh, you want a Discord? Here you go. We got a Discord." And then I'm like, "Yeah, I'd like to do it for other classes." He's like, "Oh, I already did that too. I already made it for your 201, 474." So throw Dennis a tag in the chat and throw him some appreciation. If you haven't joined the Discord, go ahead and join it. If it's going as good as I think it's going, I know, total rock star right there. I agree. I love the dab. But join the Discord if you haven't. We can make sure you guys get the links. But yep, it's all a team effort. And so, especially if you guys are working on the Discord and then you're stuck on stuff afterwards, and it seems like the Discord is being very like what I want it to be. I wasn't there for the talk. You guys are awesome. So, how we're doing? I'm putting the headphones back on. Just we gotta start out with some Zelda today. Let's go back to lecture. Oh, it's Wacky Wednesdays. You never know what's going to happen on Wacky Wednesdays. Even Wacky Wednesdays stops in midstream, stops Wacky Wednesdays. Okay. So the assignment, I think everyone knows that the assignment is now due tonight. I gave a little bit of bonus. There's lots of bonus on this assignment. I'm going to have the grader grade it, not like mean, but like some of the things you'll get or you don't get. Don't worry. Once again, with this assignment, there's many questions in it. Questions 8 and 9 are bonus. So we will talk about 8 and 9, the parts of it, I think, today. We will get to parts 8 and 9. But do not worry so much about parts 8 and 9. They're just the icing on the cake. And I think we won't even really put much of it on the first test. So we'll cover that in 474. That's why I'm like, don't worry, we'll put that into 474. So if you take 474, you're getting, when you hear it in 474, you'll be like, oh, I kind of did that as a bonus in 320. I'm good. I understand it. And so we are going to continue coding now. We've had our 10 minutes of fun. We're ready to go. Brian's got his Red Bull. Who was it? Someone said they got coconut Red Bull, and they're like, you were right, Brian. So I won't lead you astray. If you're like coconut Red Bull, get it, try it, good is what happens. Okay, let's start talking about coding a little bit more here. Now, head and tail are some of the easiest and quickest functions to learn. So with head and tail just get us the first or last so many elements when we run the code. So let's make this look nice and neat here for what we're doing. And I think I'm going to send out in the next few days a vote on what color scheme we should use. So let's do right here. Let's go to File, Save As. And then let's go to June 3rd. What am I doing? I need to use the same format. Remember, these will be posted, so you can always use them. So whenever you have a data frame like empty cars is a data frame that R has in it by default. So once again, we talked about who can tell us for 20 points how we can see what data sets R has in it. How can we see what data sets R has inside of it by default? How can we see the default data sets that are like the preloaded video games? I think I've told you guys this trick. How can we see 20 points? Who knows? How can we see the like preloaded video games R has in it? Who knows? I might have stumped everybody. I'll take question mark's very good, Connor. Connor, I'll take 20 points for that. Question mark will let us look at objects. So we can do question mark like empty cars, and it'll come up with a help menu over here, and it'll tell us about the motor trends car road test. So you can do that right there. Data, Alex, 20 points right there. You're totally right. It's data. You can run data here without anything inside of it, and it'll show you the data sets that R has in it. So here's all the different data sets that R has in it. So I think empty cars might be in here somewhere. Is it empty cars? There's empty cars right here. So data these are like preloaded video games. Casey, 20 points right there. So these are like your preloaded, pre-installed video games. You're not loading an Excel file. You're not loading, oh yeah, view packages is really good because packages has stuff in it. So Brad, 20 points. You can actually view what's in your packages by going over here and going to things like base. And we might be able to actually view, see there's values. These are all the functions you literally have, like a lot going on here. But this is everything that's loaded in. Oh, there's log 10. Hey, what is log 1p? Can we view that? I don't know how to. I've never clicked on that. So there's, and we could go here and we go log 1. Weird. Uh-oh. Something weird's going on. I'm trying to edit a function. We don't want to do that. So good. Question mark log 1p. Oh, it just told us what it was. Computes logarithms by, I don't know what this does. We could look at it over there. I've never used log 1p. So, but if you want to learn about log 1p, you can go ahead and do that. And there's so many little things you can learn about. You'll learn things I don't know. And then you'll tell me things, and you'll tell me, hey, Brian, this is a really good thing to know. And I'll be like, oh, wow. Because there's so many things to know. So what does head do? Head right here, empty cars, is going to show us the start of this data frame. Does everyone see right here? We get the first 6 rows of the data frame. What does tail do? Last 6 rows of the data frame. We could go inside of here. I need another 20 points. How is Brian going to get the MPG vector inside of here? I just want this vector right here. I want this vector of info. What's going to connect my data frame? Here's the data frame to a vector. 20 points. Who's got this? Streamlabs is a wig. Nice job, Casey, on those points. You're almost to 1,000. 1 week in right here. At the end of class, will be 1 week. Who's got another 20 points right here? Let's see. Very close, Alex. I'll give you 20 points for that, Alex. And Casey gets another 20 right there. It's Wacky Wednesdays getting up to those 60 points. James got some points also. We're going to go right here and do $sign. We're going to do MPG cars. Boom. Now we're seeing the first 6 elements of that vector. Notice the difference between the code we have here. Go all the way and look here. This is the first 6 elements of a data frame. The last 6 elements of a data frame. The first 6 elements of a vector. 20 points, everyone saying that $sign. Remember that the $sign connects variables to data frames. So here's your data frame. Here's your variable. Very important to know that the $sign right there connects the data frame to the variable. That you have to know that. You have to know that. So let's take a look. I do want to mention one more thing. Please try to knit your assignment early. Tonight the assignment is due. Literally, if you've been working on the assignment, knit it. Just try to knit it. See what happens. I will be up till, it's tough. I've been staying up lately till like midnight, and then only been getting like less than 7 hours of sleep, and I feel it. You guys probably feel it too. It's been a busy summer, and so like I was like last night I started to go to bed at like 11:45, and I was like I'm so tired, and so but tonight the assignment's due at midnight. So I knit after every question just in case. Yeah, and what you can do, if you want to do a quick knit, let me throw you guys a little bit of advice here. If you want to do a quick knit, you can now you can't submit HTML, but you can knit to HTML. We'll just call this test right here. Knitting to HTML will knit a like a web page, and you can just see if it knits. This won't bring up Microsoft Word. It's quicker. Sylvia, 20 points for knowing how to check, like just checking. And knitting to HTML will just do a quicker knit. So I'll knit to HTML to just see if it like knits sometimes. So now you could finish a question. You could just go here to knit. It's probably going to knit to HTML by default. And I've just checked that it knits, and you look at how quick that does it. Yeah, if you want to redo, then just redo, and then we'll only take the latest submission. Yeah, there you go. Sylvia, you can do that too. Nice job. Yeah, excellent work. Sylvia, another 20 points. Thank you for all your advice. Students have to hear from other students like what they're doing, because I've got my ways of doing things, but then I want to hear what you guys do. So when you typed in the code for just head, it showed the last 6. Yes, Brad, 20 points, Brad right there. So let's go back to that. Sorry, I missed that there for a second. So, and what I should mention, thanks for reminding me, is that when you do MT cars, or when you do head, it uses by default 6. We can actually see this if we look at the instructions right here, but we could choose the first 2. So when we look at the instructions for head, the default for how many it wants of an object, it'll take by default 6 of it. So this 6L right here means it's an integer. So you could literally type in here 6 capital L, and it'll just display 6. Don't worry that it says 6L. That just means 6 is being stored as an integer value. That took me a year to learn. So I'm not joking. These things, I'm like, what is 6L? And then you look at it and be like, oh, it's integer. So it purposely tells it to store as an integer. An integer takes up less memory than numeric. Numeric is double decimal precision, if people were wondering. So if you know about coding, it's just that it takes up more memory storage. So it'll hold things as integer to take up less memory when it looks at the object. So memory allocation in coding, that's fun stuff. And all that stuff right there. I think I must not seen all the code earlier. It looked like all you did was use the, yeah. Oh, you're right. No, I used both. You're right. I think I changed it. Good questions there, Brad. 20 points again. Yeah, I ran it twice. I like, you can double click. That's one of the coolest things too, is just double clicking and just changing between the different things you want. So if you just double click that right there, you can switch between just a multitude of codes, like just how you treat the vector. So if you look at all these codes I'm able to run right here, I can just change this. This is why I tell my 201 students, I'm like, you can just take whatever you want of a certain thing. And look, 6 times 6 is 36. So we have confirmed that the variance is the standard deviation squared. So if you look at how quickly we can just change this to anything we want, we'll go back to tail here because we're going to post this. Now I can't type tail. But all we're doing is using this vector and doing different manipulations on it. And there are different arguments for codes, but a lot of codes like mean, median, IQR, standard deviation can work on a vector of data. So I'm just switching between a bunch of different codes I know that take vectors. Like I could go here and go quantile, and it'll give me the 5-number summary now. So now I've just obtained the 5-number summary by saying go to this vector of data. And a vector of data, just think of it as a column of data. That's all it is. Always be checking, always be practicing. Think of the commands you know. The more you practice them, it's like playing songs. It's just playing the songs you know. And that's why I kind of do these things too, just to practice. And I'm really lucky I get to teach coding because it keeps me sharper. Because I have to explain these things. I have to know how to type them. I'll tell you guys a really quick story. The first semester I taught BAS 320, and I had to do like stuff with students. I literally had I had the computer I was working with, and then I had a cheat sheet over on the right. And the cheat sheet over on the right was like all the code I was going to write for the day, and I'd rarely ever deviate from that to try anything new. And I don't know. It was tough because I was scared, because I was like, what if the code doesn't work? And now when the code doesn't work, I'm like, oh, let's figure out what's going on. But like I said, I've been doing this since like 2015, like coding every day. And I mean, not every day. I don't like, it's not like a random, oh, no. Well, I'm teaching, probably on a Sunday I'm coding. I code a lot. And the more you practice, the better you get. And that's just the way it is. And the earlier you learn how to code, if you're learning to code in college, which I didn't do, I'd seen it. Yep. It's just tough. It's like riding that bike. And the better you get at it, the more awesome you are. And it's great. You would have a problem when you go back to change somebody would write over the characters that were already instead. Yeah. No, good question right there, Brad. If you make a subset or something, are you saying like you made a subset? Let's take a look at this real quick. Like, let's say subset. Oh no, I got to code something. I'm just kidding. This is Brian. Brian years ago would be like, no, I've got to do a subset here. We got to do like MPG greater than or equal to 20. And then there's our subset. Let's store into sub. And there's that. But now if you go down here to like to a later chunk or something, if you do like greater than 24, it's going to overwrite that. So you can't undo that. But when you knit, it starts a brand new instance of R and it knits in order. So it'll run your code in the order of everything of how it was created. So you know, be careful if you're overwriting objects, because it'll overwrite the object you've already created. It's not that bad. Like maybe I'm done using that subset. But you could always do something like call this sub1. You could stay sub, doesn't matter. Call this sub2. And then you could do that right there. So that's all right. Wondering why it's syntax that way. You should be able to. You can go to here to edit, and you can go to re-indent lines. There it is. Re-indent lines. Does that. And then code. Yeah, there we go. That keeps the syntax. So you could select all your code and then go to code, re-indent lines. So you can do that if you want, and then your syntax will all kind of be structured. And that was under code, re-indent lines, and that'll kind of re-indent your lines to all be like same structure by the way you've coded it out. Dr. Peach showed me that. No, I mean like typing in the characters, it would. Oh, I bet you. Are you saying it's doing this, Brad? Is it doing that right there? That when you type characters, it's like right here, it's doing this right here like that. Okay, then hit the insert button. Hit insert. Do you see? Look at this change right here. Do you see it changing like this? This is because insert has been hit. So I'm just clicking insert, and now insert's off. And then insert right here is on. Insert is above your delete key on the keyboard. It's probably, are you on a PC, I'm guessing, Brad? But that's probably your insert key is on. And insert will have you overwrite stuff. And now insert is off. Oh, insert's on. And now insert is off. Insert scared me so badly the first I know, right? Like, what's happening to my code? What is going on here? There's so many things that can happen. And please tell me these things. Tell me what's going on. Yeah. You're running Windows on a Mac. Oh, you're like, I'm not, what's going on? This is not what's supposed to be happening. So we've got the row number and column number. This is something we should know pretty well by now. I try to future-proof us a lot. That we see right here. This is a two-dimensional object. Please, everyone note that this is a two-dimensional. 20 points in the chat right here. I want to see how many dimensions is a vector. Here's a hint. How many dimensions is a vector? How many dimensions is a vector? This is a hint. It's almost like I'm making it. You've got it right there. 20 points. Everyone's saying it right there. A vector is one-dimensional. A data frame. This is a data frame. This is a vector. Does everyone see? Data frame is an Excel sheet. There are two dimensions to a data frame. A vector is one-dimensional. It's just a long vector. You could also write it this way. It doesn't matter. Like, when I talk about a vector, what are we talking about? I'm talking about a thing like this right here. This is a vector. But I can also view the vector this way. And then people will say to me, but Brian, this is column 1, this is column 2. And I say, no. This is the vector wrapping around the screen. That's all it is. That's the vector wrapping around the screen. Because it doesn't have enough room to print all of these right here. See, this is 2114. This is 2114. And that's 30. Wait. Have I lost my mind? 30.4. Did it do it out of order? I did MPG, right? It's not showing the whole data frame? I think it's not showing all of it. The way they show this nowadays. Yeah, because it looks a little short. Oh, this is the subset. Haha. It's the subset, everybody. So let's go here to sub MPG. And am I in sub? I'm in sub 1. There we go. That's what's going on. About got scared there. There's the 21.4. There's the 30.4. So I was in the subset. Look here where it says subset. I'm in sub 1. So when you're using empty cars in a function, we're just pulling a vector from... Yes, Alex, I'm throwing you 50 points, Alex. It seems like there was just a light bulb in your head. I really like that. When you're using empty cars $MPG, you're just pulling a vector from the data frame. Does that make sense, Alex? That's like the light bulbs I like to see. It's like, oh, I'm just going inside that Excel spreadsheet and taking this column of data. That's what you're doing. So the more you think about it, the more you're like, okay, wait, that's what's going on. Yes. You just, when you start to understand it, you're like, oh, I'm going to go here to sub 1, and I'm just going to take one of these, things. Use autocomplete. There you go. It just helps so much. And I hit a wrong button. There we go. So we're good to go. I think it's Command-Shift-Enter runs all the code. Whoa, I just found something out by accident. I've done that a lot of times by accident, and I'm like, wait a minute. I think I hit Command-Shift-Enter. So we understand here that data frames are two-dimensional. One thing you can do is you can call, I could go here to sub 1. I could go to the columns and go to MPG. And notice how this is in the column space. Let's make this very, very clear. Let's make this clear that this right here is the column space, and this is the row space. So here's your rows, here's your columns. What will this code report? What will this code report? 20 points, who knows? These are decent test questions. It'd have to be a multiple choice probably, because it can't really be a write-in. Because I just want, boom, Jordan and Emily, great job. Everything but the first row. So this is the whole sub 1 except the first row. So everything but the first row. Yep, that's it. That's it. You guys got it? And then how about this right here? Does everyone notice where we see 6 and 160, 4 and 108? Watch this. 6 and 160, 4 and 108. So this reported everything but the first row and only columns 2 through 3. You would say 2 through 3, but it's columns 2 and 3. But I could say here columns 2 through 5, and now this is everything but the first row and columns 2, 3, 4, 5, 2 through 5. Maybe you just want columns 2 and 5. So you go here. Remember, I'm in the column space right now, and you do this. Does everyone notice the small shifts I'm doing where now it just reports everything but row 1, columns 2 and 5, not 2 through 5. And so we'll put these two codes next to each other so we can see them really well. But this code right here goes 2 through 5, and this code right here goes 2 and 5. Can anyone tell me what this code right here will... Let's do this code right here. So here's the code we're going to write. How many columns are there? Oh, I can do that. Yeah, let me see. I don't have to figure it out. We can do that. Okay. Can anyone put into words kind of what this code will do? What is ncol sub 1? What's it going to return for me? If I run this code right here, that'll return for me the something. This is going to report only the what's. I wish this could be a written question. This is a perfect written question. This will return what for the sub 1? Well, not that one thing right there. Not that one thing right there. 20 points right there. You guys are right. That returns. Oh, Henry is so right. I think Henry, you're the only one who said, Henry, you get 40 points on these wacky Wednesdays. Wah. Wacky Wednesdays right there. Henry, you're right. This is going to report only the odd columns. So this reports only the odd columns. Does everyone see that? Shows only the odd columns. Corbin, 20 points right there. So we have only the odd columns are being printed because you might say, why did you put ncol right here, Brian? Because I could look over here and I could say, okay, sub 1 has 11 variables, which is the number of columns, but I could just code it. Why look over there when I can just say, well, how many columns are there? So this is a sequence going from 1 to the number of columns, and you got it right there, Jonathan, 20 points, because it starts with 1 and goes by 2. Yep, because it'll go 1, 3, 5, 7, 9, 11. Excellent job, Stevenson, 20 points right there. So this is what we like to see. I know this is more complicated, but on the first day of class, if I had told you you would understand, which I think a lot of you understand right now what this code is doing, would you have been like, I have no idea what that's doing? I mean, even looking at that now, you're like, I get it, I think. Okay, I get it. If I break it down, that, we're just reporting things from a two-dimensional object. So just look at that. We're doing some two-dimensional object reporting. And we could even go out here and we could do this. We could say columns right here. We could call this columns. And we could put these columns right here. Makes it a little bit easier. So those are the columns we're going to report. And what columns are we reporting? A sequence going from 1. So we could do this right here. From 1 to 11 by 2. This is the same sequence and the same thing. So we get the odd number of columns. So this is the same code, just written a different way. There's always infinite ways to write things. But this might help a reader see better what is going on with what we're doing right here. The 11 before was obtained by the ncol, because that's what we want. We want the number of columns in sub 1, because we're just going up to the max column. And if you run this, you will get, as we saw before, 11. So that's why I put 11 there. It was because that's the number of columns there are. But why not code that in? So understanding what's going on here is key in knowing how to work your code into code. Like you use your code to build more code. So good stuff. We know how rows and columns work. Once again, be careful where you put your commas, because once again, if you try to do a multi-dimensional object, you have to watch out. I think I've mentioned this many times, that if you go here and go to sub 1 and you say something like this, oh, I want rows 1, 2, and 3, this will treat this as a three-dimensional object. Let's just put no. Treats it as a three-dimensional object. If you want rows 1, 2, and 3, you have to go here, and probably the quickest way to code it is 1 through 3 there. So this is how you code rows 1 through 3. So does this make sense right here? This is rows 1 through 3. This is go to a three-dimensional object, return the thing in dimension 1, position 1, dimension 2, position 2, dimension 3, position 3. And just, if that confused you with the go to dimension 1, return thing in position 4, go to dimension 2 and return thing in position 5, go to dimension 3 and return thing in position 6. This is the first dimension, the second dimension, the third dimension, and this is a two-dimensional object, with the first dimension being the row space and the second dimension being the column space. How would you do rows 1 through 3 and 7? Oh, really good question, Sylvia. Sylvia, I'm throwing you. Sylvia, you're at 100. I like it when someone asks a question, says, Brian, how would you code that? I like that. So we're going to copy this, and what we're going to do is we're going to do C, and we're going to put this inside of here. There you go. And if you notice what I've done right here, I think we can see the whole thing like that, is I concatenated to join these things together. And remember, everything you're noticing right there is in the row space. So this is the row space. Remember, R reads through spaces. So this is the row space. These are the rows I'm taking, and I'm taking all the columns. So the rows I'm taking is a vector of 1 through 3 with 7 included on it. Does that make sense right there, Sylvia? Like I've joined this, like this, we call this the glue. This glued these things together. So so the first comma doesn't mess it up. Yep, you got it, because this is inside of this function. So we enter this function here, so this comma is related to the arguments with inside this function. Does that make sense? That this comma is saying do a new thing inside of the gluing function. Because we're not inside of the, We're not inside of the vector space, or not, excuse me, the dimensional space of the data frame. Yep. It's tricky. It's like, wait, but there's a comma here, but that's inside of this function right here. We're still inside this. And that's why I put these spaces right here. So hopefully you can see it. This is all the row stuff right here. Like, this is the row things we're taking, and then we're taking all the columns. So the comma is like saying, end this. Yep. Brad right there, 20 points. So if you wanted 1 through 3 with 7 and 9, would it be, let's just do it. Ben, 20 points. Ben, we're just taking Ben's code right here. Ben's practicing along with us right now, and that's what I love to see. Ben, you're getting 50, and Brad, you're getting 50. Do you have to use brackets, or it doesn't matter? What do brackets do? Everyone say what brackets do in the chat right there. There you go. Your code worked, 100%. Why do we use brackets? And there's a big thing you need to know immediately. Brackets are used, we've talked about this a few times, but why do you use brackets? For position. Parentheses are used for functions. Wait. Yeah, that's right. And then squiggly brackets. Is it squiggly? Squiggly? Squiggly is used for code running. Nice job. 20 points, everyone in the chat. Mary, you can get up to 60. I've broken the rules for 1 or 2 people. If I said, like, I put you to 100, which I think this was Sylvia. I think, Sylvia, we've broken the rules and we put you to 100. Because you asked, like, you were like, I want to see you do this. How do you do this? It's like, yes. Good questions. Getting everyone to those max 60 points on these wacky Wednesdays. So we need to know these things right here. Very important that this is a function inside of the positions we are looking for. And all the function does is glue things together. So once again, you can practice gluing things together by just writing your names, and you can glue them together right here. We got Brian and Darren, and we've glued them together. That's how it works. Practice, practice, practice. Verifying viewing specific vectors. Cool. We talked about that. Other ways to view specific entries. We talked about this a good bit right here. We talked about how to call positions and everything. Cool. Obtaining column names. Column names, there's just a quick and easy function right here that we use called names. So if you go to names, empty cars, it'll get you the column names. You can, and a few people have noticed this, you can overwrite these. So what if we want to go to position 1? Who in the chat? I'm going to put someone to 100 points. Tell me what this code will return immediately. First person, I'm going to say your name. Who knows what this return? You get pushed to 100 points. Breaking the rules on these wacky Wednesdays. Who knows what this is going to return? Should look at what I just returned and what. Yes, Alex. Boom. And Mila, we're giving you 50 there, Mila. That might max you out to 60 for Wacky Wednesdays, but Alex has now gone to 100 points. Wacky Wednesdays. You never know what's going to happen. So let's go here and call it miles per gallon. Does everyone see how now I've overwritten? Look at that. We've now overwritten it. We've gone to the names vector, and we've written into position 1. So look at this right here. This character, this word, will be stored into position 1 of the names vector. Be very careful, though. This is a bad idea. Ah! We just broke it. Sorry, MT cars. I'll have to reload R. That does not need to get posted. Well, I'll have to fix it. If I reload R, it'll fix it. Or it won't. I think I broke it yesterday and it fixed it again. But you can do some really bad things. You got to watch out. A lot of times we'll make copies of our data sets so we don't break it. Since it is already loaded data frame on R, does it just get rid of your changes if you open it again later? Yeah, so this is like preloaded data and it'll reset. Yep. Sylvia, keep those questions. Amazing job, Sylvia. Yep. These are the questions to wonder. But if you were to like have your own data, and usually that's why we load a CSV or something. Like your CSV file is not going to get destroyed unless you write over it. Like if you can, it's in one of my videos, but I could take and do write.csv. This is how you get stuff out of R. Pretty decent dimension right here. And I could go to sub 1 and I could go to subset.csv. And if I go here to subset.csv, now it should open inside of Excel. So here's my subset, and I just wrote it. So this is how you can save things out of R really quickly. So if you see the function I wrote down here, I said, write this data frame to this file. So, I mean, it's a lot of times even easier than just like clicking around on a computer. You just say, write this to the name of this. I mean, look at how little, once you start typing write this, and then just what do you want to write? You just tell the data frame you want to write, okay, what do you want to call it? And remember, what you're calling it is a word. The data frame is an object. That's why the data frame is not in quotes, because the data frame is an object. And then what you want to call it is like a word, so that has to be in quotes. Understanding the difference between the object not having quotes and the data frame being the name of the file being a word. So once again, I've just written this outside of R. So this right here saves outside of R. And we did see yesterday also we have read.csv. So I could go to read CSV and I could go to subset.csv, go away thing. And now this will read in the subset. So I've just saved it. So I could go over here and call it df or something. But this is going to read in a CSV file, and now I've saved it as df. I'll call it df a lot of times for data frame. It's kind of my just like, if I just want to call something data frame. It also, the way it stored it, it put the row names here. The row names are now X, and it changed this. This is different than the original mtcars data frame because it put the row names in the first column, and it's now called column X. So guess what? This is going to be a 300 points right here. Who can write a code for me to change this right here? I want to change this to be called name of car. Take a moment. I don't care. I'm putting this to 200 points on these wacky Wednesdays. Write a code for me. Help me change that. Help me change that X. Who can do it? Help me change this X right here. I'm going to take your code. 20 points for taking a guess at it. You can only get up to 60 unless I say we broke the rules, but we're breaking the rules for some of these wacky wins and giving 200 points. Mila, I think it's... Let me see here, Mila. Mila, that works. Mila gets 200 points right there. Mila, you got it. It's not the way I thought of. I'm taking Mila's code. Mila's got the points. Did what Alex right. Look right here. Mila, I think you've done it. I'm gonna take, and then also Corbin, I think so too. So Mila and Corbin. We're gonna look at the two ways suggested right here. So here's Mila's way, and here's Corbin's way. So Corbin was the first here. Everyone else gets 20 points. Mila and Corbin, we've broken the rules on these Wacky Wednesdays and given you 200 points. We're just going crazy here on these Wacky Wednesdays. And so let's take a look right here. Mila's way, which is an excellent way. It wasn't what I was thinking. That's why I paused. And so it's still 100% right, though. What Mila's doing is they're taking the variable and they're putting it to a new column. Super quick and super easy right here. So this is going to put a new column to the data frame. So now if we look at the data frame, it's going to be at the very end of it. It's probably going to wrap around the screen, which is all right. Perfectly fine. So let's go to the data frame. And the new column has been appended here with name of car. Great. Mila, did you ever think you would know the answer to like like that? I thought that'd be a very tough question, and it was. But you were just like, oh, let me just save a new column using my data, and just that's what Mila's code does. Just takes the original column and stores it in a new column and gives it a new name. And what we could do is we could go right here and we could go to df, who knows for 20 points what Brian is doing here by doing that. What is Brian doing? You can tell me very quickly, what is this code doing right here? What does that code do? Yep. It's gonna do what though? What's it gonna do? You got it, Brad, 20 points right there. Deletes the first column. So now if we look at this, look at that. We did it. We did it. We could, and there's ways that we could actually reorder the data frame. If I really wanted the data frame like reordered, I could go here to data frame. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is there 12? There's 12 now. I could go here to data frame, this, concatenate 12, comma, 1 through 11. And there. So this code right here reordered the columns. So now look, name of cars is now the first column in the data frame. Can you move columns around? Yes, Jordan, right there. There you go, Jordan. Yes. So now we've reordered them. So all we did was say report them in this order. So if you look at this, we've now moved them. Jordan, great minds. Jordan, 50 points for those great minds. You might be maxed out there. I'll like it. Great minds right there. Like, wait, can we move it back to where it was? Yep, we can. We did it. See, these are the things I feared that I wouldn't do. Like, if someone said that in class, I'd be like, email me later. We'll figure it out. I mean, not that if I say that now, it's not like I don't know how to do it, but I'd be afraid. I'd be like, I don't know if I can code that. But now I'm like, ooh, let's move it around. But okay, we're going to look at the other way right here, which I think is totally easier. And I'm still giving points for this right here. Still giving points right here. We're going to call this, what was it? Name of car. That needs to be in quotes. Remember, if it's a name, it needs to be in quotes. And this is probably the easiest way, which is fine. Totally fine if we do it different ways. We're going to go right here. We're going to reload the data frame. We're going to take a look. If you notice, it's calling it X. We're going to go to the first position, which is... Oh, it's empty cars. DF. We're going to go to the first position in DF. And DF is S. It's X. Don't know what it is. And then we're going to overwrite that. And then we're going to look at DF again. And guess what? There we go right there. We've done it. So excellent stuff right here. Just looking at what's going on, we can overwrite the name that was X with the new name right there. Can't you also use the name of the vector instead of the position? Yes, I bet you could. Brad, I'm putting you at 100 points. Let's go here to MPG position in the vector. No, I don't think you can, because I don't think this has... We'll find out. I think I tried this yesterday with 474. Yeah, it doesn't like it when the names vector doesn't have named positions. So you actually have to put in like 2, and that works. And now that has been called miles per gallon at the top. And it's so long it wraps the screen now, because it's the data set just kind of goes around the screen fully. So good question right there. It won't let you do that with the names vector, which I wish it did. I think I investigated that yesterday also, because I was like, oh, can't we just do this? And I was like, oh, we can't do that. So these are the questions we ask, and then we give it a try. All we do is if we wonder something, we just try it out, and we see what happens. So there we go. Great work. Great questions. Obtaining the names. We've seen how to do the names. Data frame names. Cool. That's saving it as a data frame. Cool. I don't do that much. I don't know how to do that. Renaming columns. We've seen how to do this today right here. Renaming the columns. We're calling the column name 2, and we're overwriting it with solar radiation. Always try to read this as a sentence. I can't state that enough. Go to the names for the data frame and go to position 2, the name in column 2. Overwrite it with solar radiation. Yes. Oh, did you? Send me that code if you did. Send me that code, Brad. Maybe you did. Maybe my mind's not 100% today. So we have right here, this is overwriting all the names. I use this so much. I use this all the time, inserting a vector of names. So this would rewrite all the names. So if you were to have a smaller data set, like let's say we had here DF, it was DF columns 2 through 4. So now you could go to names of DF, and you could overwrite with the vector name 1, name 2, name 3. Because there's 3 columns right now. And now if we look at DF, they've now been called name 1, name 2, name 3. I do this all the time when I want to rename my columns, because I'll see like that there's all these names I don't like, and I'll just go through and I'll write a vector of names. You could even take this right here, and you could call it like call names. Sure. I don't like when you have a similar object. And then you could do that. So now you write all your column names here, and you might do this later so you can see like here's the name of column 1, name of column 2, name of column 3, and then you could overwrite these column names to the names of the columns right here. So if that was like MPG, and this was horsepower, and this was weight or something like this, you could just do that, and then you rewrite your data frame, and you've got it right here. And so the smart thing is that you can easily kind of recode stuff right here, and you can just handle it. Send me it there, Brad. And yeah. Oh, that's awesome. The way we renamed the vectors the same way we did rename the levels as well. Yep. Right here, we can see renaming the levels. Great answer right there, Alex. Alex, amazing job. Another 20 points. So if we go here to library reg class, and we pull up data survey 10 and we go here to levels of handedness, which handedness, then you can go to the levels vector and rewrite. Now watch this. Let's go to the levels vector and rewrite this as A, comma, L, can't type today, R. And then we take a look right here. Watch this. Survey 10, handedness, and it's recoded all of those. So if you rewrite the levels vector, you can change the name. You can rewrite everything in there. So you don't have to like, think about how much quicker this is than Excel, is that you don't have to go through and like rewrite everyone who put in right or left. And I could change these back to ambidextrous. We're going to abbreviate that because I don't know how to spell it. Left. And I could go here to right. And now when I take a look, everything's been changed. Look at how quickly I can change all the data just like, I mean, I know it wouldn't be that hard in Excel to do find and replace, but maybe it's somewhere else in the data sheet. I guess you could highlight that vector like within the field you've selected. You could click the column. You could go to find this, replace with this. But I could just go to the levels vector and say, I could view the levels vector first. I could say, let me view it. Okay, there's 3 levels. Let me overwrite those 3 levels with these things right here. So it's very, it's like Excel can do everything kind of, but there's not really a good and quick way a lot of times. Like it takes a lot longer. With this right here, we're just instantaneously overwriting all the levels, and that also changes the variables. So does this seem pretty quick and easy to you guys right here? Like, what do you think? Is that better than Excel, or should we start teaching the class in Excel? I don't know. It might freak out. People might start voting Excel. People will be like, oh, let's just use Excel. Let's just learn everything in Excel. I'll be like, there'll be things later on we definitely can't do in Excel. Dear God, no. No. My eyes. I need that guy from SpongeBob. So I agree. Yeah, it's way better. It's way quicker. Excel is all right. What's the easiest way to replace 2 levels with different values to the same value? Oh, okay, yeah. So if you wanted like, let's just have, who do we not like today? I'm letting you guys pick. I'm gonna pick, do we not like ambidextrous, left or right? Or who do we like? Sorry, this is gonna be the person we like. I switched it. So know that whoever someone says we're gonna like these people. We like left-handed. So we're gonna call these other. I'm going to call this other. And then we take a look, and we have this, and we take a look at the levels vector. And there it is. So now I've overwritten ambidextrous with other, and I've overwritten right with other, and the levels vector only has these 2 things right here. So I've recoded ambidextrous to other, and I've recoded right to other, and we only have left and other. So it put those levels together. So now there's only the 2 levels, and I can't undo that unless I just reload the data. Now it's been undone. But then I could just overwrite it again. Just do this, and then it's overdone. So does that reverse? There is no undo in R, which is one of the questions that people posted. True, false. Is there an undo button for what you do to your data? No. Brennan, 20 points right there. Ben just got Uno. Jonathan, 20 points. You guys are awesome in the chat. I love the jokes. I love it. Like, that's what makes the class, is me looking at the chat and just, like, seeing the fun. Here we see with adding the column right here. We've got adding the columns. We saw this earlier. Great job, Mila, on adding a column right here. They're adding a factor to this with the levels of this. This is a very small data frame, so it's going to be, this is the new column they're adding in, is weather, and it's going to be a repeating sunny, rainy clouds. It's going to save the first 4 rows. Oh, so it's a smaller data set. And then we're going to put a new column in. Since it's 4 rows of data, it's just going to be a new column. It's because it'd be too long to put on the slide if not. Adding a new column just denotes something that does not exist. Adding another column, you can do this right here. You can put in Celsius and all this good stuff. You could overwrite a position. Cool. Adding yet another column. Cool. Once again, please note that this is using cbind, which is column bind, and then rbind. Have we talked about column bind and rbind yet? Row bind? Have we talked about column binding and row binding? I've got a pretty good example. I don't think we did in this class yet. I get flashbacks. We did? Maybe you saw in... Yeah, I think, Dennis, you might have been in the 474 when we talked about it. So imagine this. So yeah, no, that's what I was thinking, Dennis. I get you see, that's what happens is I teach it in another class, and I'm like, I just talked about that. So guess what? Dennis knows we got a good example right here. Let's do our classic voting. You ready? We're going to bring up a vote right here. So I'm going to get it right this time. Dennis remembers from the other class when I confused them. Today I will not confuse you. So the vote is going to be, will we use C-bind or R-bind? Are we going to bind together columns or are we going to bind together rows? Now, Brian and Darren, growing up, we would watch Sports Center. Da-da-da, da-da-da. And that's all I know. Da 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 da. Don't answer yet. And so Brian and Darren want to collect data on their favorite basketball players. Mine was Dennis Rodman because he's awesome, and Darren's was, I don't know. I'll have to ask Darren who he liked. I don't know. Dennis Rodman also because he's so awesome. I really do like Dennis Rodman. I loved seeing him play. That guy's just, I like big personalities, and that's I mean, he's also great at basketball, but but anyways. Oh, we decided to collect. Don't vote yet. Don't vote yet. Don't vote. You might want to change it. Don't vote. Don't vote. I'm gonna personally make it the other answer now. Now you're gonna vote the other answer. Okay. So we're collecting data on our basketball players. You guys are cracking me up. And Brian and Darren collect data on their favorite basketball players, and they want to collect 5 different variables on them. They want to collect on like the amount of points they get per game, the rebounds they get per game, blah, 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 blah. Yeah, I know he's crazy, man. He's crazy as in awesome. And so Brian collects 50 basketball players. Oh, shoot. I shouldn't say the answer. I shouldn't do that. I'll do that first, right? Brian collects 50 basketball players and Darren collects 50 basketball players, and they merge their data sets together. What are they going to do? Brian collects 50 basketball players and Darren collects 50 basketball players, and they merge their data sets together. Yeah, you're seeing it. I'm showing the answer if you're seeing it. Well, some people see it. Brian collects 50 and Darren collects 50. Do you see it? Yes, you're seeing it. So that is a row bind because you guys are getting it. It is a row bind because we're collecting 50 different basketball players together who will complete this poll. Great job on the poll here. We got the votes in, but we're going to start a new poll now in a moment. You guys can guess. I won't do the next one's poll because it'll be the opposite. So when would it be a column bind? Does everyone understand? If we're collecting all these basketball players, each basketball player would be their own row. And if we join the data sets by 50 basketball players here and 50 basketball players here, they're going to be bound by the rows. Like you're just putting together 50 basketball players and 50 basketball players. So imagine this. I might trick you here. Watch out. Tell me rows or columns are going to be bound together. You work for a financial firm, and people from different regions are going to take all the banks in their regions and join them together, and they've collected the same variables. So you work for, so type in the chat, rows or columns. Don't vote on this one, don't worry. And I think Jordan has a question. So let me repeat the thing here and I'll read the question. You work for a bank and people in different regions will join together their data frames. They've collected all the same variables. And they're going to join it into one like national data frame for all the banks. If you collected some stats on all the players and you collected other, yep, Jordan, that'd be a column bind. If Darren went and collected like 5 statistics and Brian went and collected 5 different statistics, then we'd join it on the columns. And of course I did another row to see if I could catch you off guard. If you have all these data sets from like different regions and you're joining them together and they all have the same variables. So I guess a good note on this is like, if you're joining together different observations by the same variables, that's row bind. So here's a quick note. If you're joining together different observations by the same variables, like different people or things, then you're joining on rows. If you're adding new variables to a data frame, you're column binding. And let's look at this. You're column binding because you'd be adding new variables. Does everyone see to bind a column to this, you'd be adding a new variable, but to bind rows, you'd be adding new cars. So maybe that helps a lot to see it this way. Binding rows to this would be adding new cars to this data frame, and binding columns would be adding new variables. Yep. Different observations by the same variables. Mila, 20 points. Great job, Mila. Excellent notes in the chat, because that's what I want to see. I want you guys to be like, okay, I get it. This is what we're doing. That's how we would row bind and column bind. Excellent work. So we know what's going on with these. It clicked with the graph. Yeah, I try to think about how to show it visually, And Brennan, that's what, yeah. Like, so I'm like, wait, if I show that, maybe it'll make sense when you see it. Like, oh, it's like another car being added on here. Oh, it's another variable we collected being added on here for column binding. So this is column binding and this is row binding right here. So Brennan, 20 points. Thank you very much. That helps me know what to show. And I try to figure out new ways to show everything to you guys every time. Like what clicks? I'll be showing that again next time I explain it. So cool. That's what a data frame looks like. Nulling it out removes this. We've seen this a few times today. So if I show something quickly, it's usually because we've seen it. You null it out, it goes away. We talked about null yesterday. Null means nothing, nothing. So when you save null into weather, it doesn't exist. That's like me calling right here. If I go here to Brian, let's say null. It says Brian's not there. It says it can't even find it. What if I go to data frame Brian and say Brian and data frame Brian? I can't find the data frame. Let's go to sub 1. Let's actually get it to say null. And let's go to Brian, and there we go. Now it says null. So it couldn't even go. It tried to find object Brian. I mean, object Brian is probably a null object. A lot of questions here. Like, I'm sure Dennis and I are wondering, like, did we test to see if null objects take up space? Wasn't I trying to make a list of all null objects? I don't think we figured out yet if a null object takes up space. But what's the easiest way to duplicate a vector? You go here to sub 1. You could go to mpg car, and you could store mpg car into, let's go here so we don't wreck it. We're going to go to sub 1, mpg duplicate. There you go. So now we've duplicated the vector right here. If you look at the end of the data frame, there's mpg duplicate. So right there, null objects don't take up space, if I remember correctly. Yeah, I think you're right. Dennis, 100 points, because you just rock star today and always. Yep, no, good questions. Ask these questions right here, Alex. Be like, how do we duplicate it? Just take the vector, store it into something new, and this is how you create new columns. And you say, you know, I don't want that anymore. I'm done with that. It just go away. Now it's gone. I destroyed it. So I'll put that code in here in the order so we can see it. I should have kept the other one. Oh, we can null it out. But this, I created something and then I destroyed it. I wonder what happens if I try to null it out. It's like, well, yeah, it does it. There you go. I tried to null out something that didn't exist, and it was like, sure, I'll remove something that does not exist. But this no longer exists in this data frame. When I call it, it's nulled out. This will create it. There it is now. Oops, I clicked the wrong button. There we go. And that'll null it out so it goes away. Understanding what nulling out is very important. It's just the quickest way to delete columns. So we see this right here, nulling it out. So null it out. Adding rows. We see right here, row bind. We talked about this. Add rows. Important. Removing rows. You can do the old deleting out. There's a lot of ways right here. You guys saw me do this earlier where I overwrote a data frame with rows removed. So you can just store into the data frame. You could make a new one. Here's making new ones right here. It all depends. Like, these are just all 3 duplicates of the data frame being created, and then we're manipulating them. Once again, I was doing some really bad ideas today because I overwrote empty cars and I destroyed empty cars. A lot of times we'll make a duplicate of it. So, you know, before you start manipulating things, you'll go like to df for data frame, you'll call empty cars, and you'll just store that into here. So now we have, you know, the df here, and whatever we do to this will not destroy it, even though Brian destroyed the column names. We'd have to reload R. But this right here would allow us to manipulate and make 3 separate changes, whatever we want. Autocomplete tries to help, but that'll allow us to kind of manipulate and do what we want without changing it. Didn't take up any memory in the global environment, at least. Yep. And it might be so small. Global environment won't tell you if something only takes up a little bit of memory. It only tells you usually for big objects. We've talked about subset. We've done this quite a few times, so I'm not going to cover it because I think we've done a lot of subsetting. Also, please note, yesterday after class, who got a lot of help yesterday after class and got a lot of the assignment done yesterday at like 11:30 to 1? Did anyone stay and get a lot of help? Because I'm sure today we'll be doing the same thing. I'll be here today after class, doing a lot of help. So if you are stuck on anything, please show up at 11:30. Yep. And I'm sure a lot of... How much did you guys get done? Emily, James, Casey, tons of help, Nicholas. How much did you get done? I went and watched the video later and it helped a lot. Awesome. Yep. And for some reason, the video stamps yesterday are not posting to the video. I literally copied the stamps from the day before to see if it was working and put them in yesterday's video. And Yeah, and that's the thing is like watch the video afterwards or hang out after class. Like 11:30 is when I do office hours and I stay till about 1-ish. I mean, if we're still working and I don't have a meeting, then I'll do more work, but definitely stay, get work done, look through the video afterwards. And I'm sorry that the timestamps are not in yesterday's video. Also this, if you guys notice, I will put these in the video. You can put things like 3:30, 45, or this right here, we'll do 45. Question 4A. If you put something like that in the video, I'll give you 10 points. You can, so if you can't attend class, like these mornings I can't attend, and if you're watching a video and Brian works on a question, you can mark that and I'll see the comment and I'll put that in the description. And as long as YouTube chapters are working, it didn't work on yesterday's videos for some odd reason, as long as the chapter things are working, that'll highlight in the video when I'm working on certain things, and that'll help your fellow classmates find things in the videos. Because I know the videos can be a little bit long, and it would be, you can even do things like this. Anything you're watching in the video later, you could be like, you could do something like that. So you can mark anything you want in the video, and I'll try to add those to the tags in the video. So when you're watching this, just don't be like I have to tag. Don't be like I have to tag the whole video. But if you think there was something really important that people might want to see later on, I put in like the general, like when I'm lecturing what and what. Excuse me there. But tell me, you know, what you think. Add in your comments. I watched Office Hours later yesterday and help me with question 7. Yes, that's what I want. And so if you can't watch them live, I want them to be posted, and that's my goal. Is that I explain it, we walk through it. Selecting a subset on a large data frame, cool. Subset example, cool. If you've watched yesterday's video, we did a lot of examples yesterday, and we've also done a lot of subsetting so far in this class. So I think that's why I'm kind of doing it a little bit quickly because we've done these. Drop levels, I'm going to mention this briefly here because this is in the assignment. If you have unused levels, so let's say we go here and we go to subset survey 10, and so this is a subset example. We've put this notes many times in the chat. We go here. This is what we're subsetting. I'm going to go here to handedness, and handedness will equal. Let's do this percent and percent because I'm going to pick the people who are either right, sorry, ambidextrous. I'm only not choosing you because I can't spell, and left. So now this is a subset of only people who are left-handed or right-handed. I could have done not ambidextrous. So I could have said, like, choose the people who are not ambidextrous. That'd probably be quicker, and I would just put a not. So if anyone's wondering, now I got to spell ambidextrous, right? I'm going to cheat. I'm going to go here to levels. What's interesting and what I want to point out here is that, oh, no. There we go. Here's ambidextrous, and to choose the not ambidextrous, I could say not equals to, so these will be the same subsets. So if you look at the two codes I've made, I could choose left. I could choose people who have a handedness contained in the vector left or right, because that's like choose handedness contained in the vector left or right. And this is the way you should code when it says like choose this, this, or this. It's in yesterday's video. But since I'm only not choosing one of them, I could have just said choose handedness not equal to this. So that's the not equals, which I figured would just be a good thing to kind of review again. This would be only choose ambidextrous. This would be choose not the ambidextrous. So the exclamation mark. Yep. Oh, I don't know. I've never tried that. I don't think that'll work, but I'm throwing you, Sylvia. I think I'm putting you at 150. I like that you asked. Like, what you could do, Sylvia, is there is a way to do it. You could do, I bet you could do this. Take this and do that. This should work. That works right there. You have to put the not on the outside. So then you would evaluate that logical vector and then flip all of them afterwards. So remember, this inside of here creates a logical vector. So I created the logical vector, and then I flipped the logical vector. So there's the logical vector. This is just logical vector, and then I flip my logical vector. So everything that was true becomes false, and everything that's false becomes true. So that's not contained in now. So that's how you could do, there you go. That's how you do not contained in. And Sylvia, that's 200. Like, that's the max I've given today. And your questions are making me think, which that's really good right there. If you make me think, I'm like, ooh, Good questions. Good stuff. So we don't want the not. We can actually leave the parentheses. It won't hurt anything. It'll do its parentheses thing. And we can confirm here. Let's look at our subset. So everyone see the subset has 23 observations. And if we run this code right here, oh, we're only choosing the ambidextrous here. Oh, we want the not, right? So we do want the not. So there's 676, and there's 676. This confirms. So a lot of it was figuring out the correct order of operations in a way. Yep. That's what it is, Sylvia. It's like figuring out what do you do first, what do you do second. You have to figure out the correct order of operations. And this right here does the same thing. So now check this out, though. We now have a subset without the ambidextrous. If we go to sub-handedness, then what do we see right here? We have ambidextrous still here, but there are no ambidextrous. You can confirm this by going to table, sub-handedness, and there are 0 ambidextrous. So one thing you can do, which I forget it works this way, is you can just go to sub, store into it, drop levels of sub, and that works. I forget it works that way. That is that easy. Because now if we run a table on this, there's no ambidextrous. That's the easiest way to do it. You could do it for the vector, which is the way I usually do it. You could do... Stop being mean to me, R. You could do it for the vector right here, where you only drop it for the vector, which I guess if you want to be exact and only drop the levels for the vector, that code will not do anything now. It's already done what it needed to do. This is the way I usually use it, but you could just run it on the whole data frame, and it'll go to every factor that has unused levels. So what does drop levels do? It drops the unused levels. Here's ambidextrous. We dropped levels. Ambidextrous is gone because ambidextrous has no levels. So this is very important because, especially when you're reporting, do you want to report that there's no ambidextrous, or do you want to not show that because it's like, well, you know, what if there was like 50 levels that had 0, which is what we see in some data frames. And that's what you'll see in yours, is that if you make a table of major, you'll have like 50 unused levels. So while it makes sense to say that we had no accounting, or we had accounting, we had no supply chain, we had no nursing, we had no engineering, we had no blah, 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 so many, it becomes cumbersome. If you were doing something like a survey for the Haslam College of Business and you said we had no finance majors or something, okay, that's all right. But if you limit your thing to only 3 majors, which we do in this homework example, you don't want to then say, well, we had no this, 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 and this, because we're only looking at 3 majors. So why are you saying we didn't have any this, 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 this? Because it was like, well, of course, we only limit ourselves to this. So once again, a big thing is you want to look at what the question's asking, because it all depends if you want to drop levels or not. It's like, well, when would we use it? This is big right here. This code right here, boom. I want to go to my subset. Who was saying earlier to use Control F? This code right here is just the answer to how to sort data frames. It'll do it for you. Watch this. I'm going to go to my sub. Boom, sub. I'm going to go to sub. And then here's the variable I want to sort by. So I want to sort people by height in here. And now my data frame's been sorted by height. Let's overwrite sub. And let's write it right here, and let's take a look at sub. So here is sub, and we've sorted everyone by the height. Please take a look at this code right here and realize that it's right here. And all you have is the name of your data frame, then the name of your data frame again, and then the name of the variable you're sorting by. So all you need to change is, what is my data frame called? So mine was called sub. Here, what's your data frame called? Yep, decreasing equals true is the same thing as increasing. Oh, Brad, can you really do that? Brad, does that work? Oh, it doesn't do it. Yeah, increasing equals, it would be the same, but there is no increasing argument. Brad, you're at 100. Big questions right there. I was so excited. I didn't know if there was an increasing argument. Oh, no. Yeah, it would be the same as increasing equals false. So decreasing equals true will be, it'll decrease from the top. Like, it'll start with the highest number, and then they will decrease going down. Does that make sense what decreasing equals true means? Decreasing equals true is descending order. So decreasing, descending order. And then decreasing equals false is ascending order. It'll go up as you go down, because it'll not decrease. It'll go up. So it should be like, so decreasing equals true means the numbers will start with the highest number. And we can confirm this by looking here and seeing that we start with the tallest person in the data frame. and then everything just goes down in height. You can see the heights. This is decreasing equals true. And then we go here and do decreasing equals false. What? Remember, 0 is false. So that's decreasing equals false right here. And now the data frame starts with the shortest person. I did that just to show once again that zeros are false. You can just type a 0 there. You can also type an F and pay F for respect in the chat. No one's going to do it now. And so there we go. But F and 0 are the same thing as false. If you notice, they change colors. 0 is the value of 0. Thank you, Ben. 20 points, Ben and Corbin right there. Press F for respect. So, see, hopefully I know memes. The more I say that, the more old I sound. I tried too hard on that one. I'm like, Brian, Pog, I like it. F in the chat. That's what I got to say. Every time. See, we get to type that because of us. Here's examples of sorting numerous columns. This is not any of your assignments, and even I'd have to double check. So we're sorting by party size and then by bill. So party size is being sorted first, and then bill within party size. I will say this, dplyr is probably a package to learn for this. Not probably, but it's a really good package. So dplyr would be a good data manipulation, data sorting package for that. dplyr is awesome. Lists. Okay, let's talk about lists for half a second. So the way lists work, I'm not a big fan of lists if you can't tell. When it comes to lists are basically like a folder. Think of lists as a folder where you can put anything you want in a list. So when I go here to make a list, I can go here to list, and I'm going to call the function list. So you got to watch out because now I have something called list, and then the blue one is the function list. I'm going to put in here sub for and the vector Brian Darren. So now inside of list, when we take a look at list, we have inside of list here, the data frame is the first thing. So here's my data frame as the first object. And then the second object is for, and then the third object is Brian Darren. Now, it's giving you hints here of how this is called. So when you do lists, you have to call the objects in lists with double brackets first. So if you notice, if we go here and we do list, double bracket 1, what do we get? We get the data frame. If we do list, double bracket 2, what do we get? We get the 4. If we do list, double bracket 3, we get this right here. So where it gets confusing is if we do this, we should get, I'm going to cross my fingers. So we're going to get, hopefully, the MPG vector, the MPG column. It's subset, so it's males and females. Because that was I subsetted that. So this is the first column of this object. This right here refers to the object now that I'm inside of it. Because this might as well just say right here, sub. Because the first object in the list is this. So now I'm just calling the first column of this. But it looks super confusing when it's written like this. But remember, this object right here is just this right here. That's what this is. Like, you can just think of this as that, and then it's pretty obvious we're calling the first column of the subset. Because when you look at this, you're like, oh, that's the rows, that's the columns. Now, if we go to list object 2, we should get a dimension error. We do get a dimension error because this just has one position in here, and it's just 4. I could change this, and now this right here, when we get to here, we have 2 objects. We have Brian and Darren, so I could call this. And the best thing to do when you think of lists is just realize that you're making a folder of certain things. You're just saying this is going to be with this is going to be with this. A lot of your output in this class, and this is something I wish I knew earlier on, will actually be a list. I'm going to make a very quick model right here. So this is something we'll be doing later on. Height tilde weight comma data equals. We'll be doing this like next week. And survey 10. And if you notice right here, this is a list. So you could call things in the list if you really want, which I didn't start doing for a long time. There's your coefficients. There's your maybe residuals or something. It'll tell us probably at the top. That's so much. We could open this up. And we could see what the objects are inside of this. Coefficients, attributes, residuals. Oh, it's residuals is second. Effects, ranks, all these things right here. So don't worry, we don't go this in depth in the class, but you can just see this is an object M right here. but you could always call like M and go inside of it this way also. Lots of stuff going on. We can even just go summary of M. And these will be very important codes later on, and that's literally how you do a regression. A regression in this class is just as simple as making your regression, running your regression. Look at all this output you get right here. You get your residuals, you get your coefficients, you get your estimates for the model, and you get all this. So this code right here will be about how hard you will have to code in this class going forward. So like when we get into regression, you will need to know y tilde x comma data equals. This is the formula format right here. And then this is the data frame we are using. And then we make a summary of it. And guess what? Do you see that object M? Watch this. You ready? Here's how I can visualize the model. Visualize model M. And that makes a visualization for me, which is being crushed in the screen right now. We go to visualize model M, and it makes the visualization. What if we want to do something like, let's go here, and let's go to residuals of the model. There's all the residuals. What if we want to predict for the model? There's all the predictions for the model. So if you notice how quickly I can do all of these. Extrapolation check, I think we can do that one. It needs new data for that. We do confident for the model. There's confidence intervals for the model like that. Confidence intervals just like that, confident. So if you notice, I'm just manipulating this model M right here. And the coding does get a little bit easier. This is the things that Andrew was alluding to, is like, you'll build up this knowledge. We're giving you more than enough knowledge to do the things in this class, that when you get to the later stuff, you'll be like, this is easy. And frankly, we should make it harder, I think, sometimes. I'm like, oh, it's too easy at the end. At the end, you'll be like, oh, it's so easy now. And you'll just, I don't know. Just wait. I promise you. Stick in there. Oh my gosh. I got to try that now. Visualize model 3, 1 through 2. So I'll give that a shot. I don't know. Visualize model is a command Dr. Petrie wrote. So this is in reg class, which means Dr. Petrie wrote it. Visualize model of list. Oh, wait. Okay. So you're saying go to my list, and inside of my list, there's the list object, and go into here to, no. Because the object 3 is going to be, so visualize model takes an object M. So it takes a model object. It has to be fed a model. So that's the only argument it takes is the model. Does that make sense, Ben? 20 pence, Ben, right there. Really great question. Visualize model only takes one argument. It takes M, or like you could call this model, but it has to take a model. So visualize model has to take a model, and it visualizes the model. And what does it visualize? Linear models, logistic models. So we can't put in here a list because it tried, but it didn't do any output. Yeah, no, great question. No, I love it. I love the questions. I'm throwing you 100 points, Ben. I mean it, because I want you guys to just, whatever you think, ask. That's the way the class goes. You think it, you ask it. I mean, lists are cool, I guess. List apply right here is actually very, very good. And I'll tell you why list apply is a very important function. Because list apply, I literally used this yesterday with helping a student out. List apply right here can be used on data frames. Like, what? It's list apply. We can actually go here and do list apply on a data frame, that's the graphical error, and apply a function across a data frame. So if you notice, it did a summary of every vector in the data frame right here. So we got a summary of every vector in the data frame. Now, let me go here. I'm going to store a subset of this data frame. So I'm going to store into here sub columns 2 through 7. And now watch this. I'm going to overwrite it. I'm going to do mean. And what does it do? It gave me the mean of all of these columns. Does everyone see how quickly I can get the mean of every column? I could get the 5-number summary of every column here by calling quantile. And now we have the 5-number summary of every column in the data frame. I can make a table of every column in the data frame. And we were using this yesterday. I was working with another student. He's doing a project. And this right here shows us how easy it is to just run a thing on multiple columns in a data frame. So whatever I put right here, whether it be like median, it'll get the median of every single column in the data frame. So this is very, very, very helpful. to be like, oh, I just want the median. Now you might say, Brian, why did you reduce your subset? Does anyone know here? Yes. Oh, did the comma right here? Because I want all what's. Ryan, 20 points. This right here is saying take all what's. This is saying take all the... You got it, Brennan, 20 points. And then this right here is columns 2 through 7. So this is the column space. This is the row space. So that's all the rows. You know what I might be able to do? I won't do that. I was going to store a blank vector into it. Yep. So that's what that is right there. Good questions. Good questions right there. Ryan, 20 points. So ask those questions. Data frames as lists. They're lists. I said that. And yeah. Good stuff right here. Nested. There's just a little bit extra. It's just how R works. And just tells you. We're going to look at... Let's see here. There is the bonus on tonight's assignment. We did not cover it. That's okay. It is bonus. We will talk about it. I might just leave it as bonus and not talk about it. So I might just leave it completely as bonus. It is in the video from yesterday for 474. I'm going to look at our time and everything, but it is bonus. It is just bonus. Remember that. Questions 8 and 9. Can I see it in the chat for 20 points? Everyone's probably getting maxed out right now. Everyone's probably got their 60, and some people got some wacky Wednesday points. I want to see in the chat, questions 8 and 9 are bonus. So that way people don't get to them and they're like, we didn't do this. What the heck's going on here? Oh no, I spent 5 hours, Brian, and I got nowhere. Email me. You can email me about the bonus. So we got our advice on the screen right here. So let's put use Discord. Is there a question that someone's stuck on? Let's solve one question here. We got 4 minutes. Let's use the 4 minutes. Someone put a question they're stuck on, and we will solve it right now in the 4 minutes we got. So, what the heck is a lift? Are you talking about lift in market basket analysis, Alex? Are you talking... So, someone put a question in the chat that they're stuck on. It'll be like, I can't do... Oh, does it mention lift? Does 8C mention lift? Oh, gosh, what did I do? What did I do? Is it, is this your guys? Am I in your guys or am I in 474s? I'm in 474s. Is this it? Oh, yeah. No, of course it does. Yeah, there's no way we're getting to this right now. So this is... I should not have put this on here. This is 9. Wait, it's 9. So, yeah, don't worry about this. This is just... Lift is... I was like, how do you guys know about lift? Lift is the factor increase. 9B, I was like... Because 8 is time-related objects, is it not? 8 is the time-related objects. If I was you guys, I wouldn't even worry about 8 and 9. I put them as a very low bonus, I realize. Do not do 8 and 9. My suggestion to you is don't do 8 and 9. Don't do 8 and 9. Hey, it's a rainbow. My suggestion for life would be don't do 8 and 9. Don't subject yourself to them. So that'd be Brian's. 8 wasn't horrid, but 9 was out of... Like, let's do 9 right here. Ready? I'm gonna start doing 9 right here. Why not? I'll get 9 done. You ready? One issue with data is the missingness of data. So right here, because the rows, what fraction of these values are missing? Using the... Okay. So what data frame are we using? I should have the data frame loaded up. The OPS data frame. Do I have OPS loaded up? No, don't restart. I don't think I have OPS. OPS, that's not the OPS data frame. OPS a function. So let's see right here. I know, right? It's a long thing, and that's why... Let me go get the OPS data frame. 2 seconds. Gotta get the OPS data frame. OPS. I'll put this at the... So this is at the end of the video right here. I'm gonna go grab some OPS data frame. OPS data frame. There it is. homework1-ops.dat. Read homework1-ops.dat. Yep, and then yeah, that's what I thought. And let's go to session, set working directory, choose directory, downloads, click open, got it, load, got it. Call OPS, OPS stored, OPS. Okay, so this is how we do this right here. We want to know what fraction are missing. And you know what's really funny is I literally just did this yesterday with the student I was helping out. So this is how you do this one right here to find the fraction of missing data. We're going to look for the fraction of missing data. So think about this. If we run, clear that out right there. My little box, my little home inside of here. So if we want to find the fraction of missing data inside of here, we're going to go right here and we're going to go to is.na and we're going to go to OPS. That'll tell us trues and falses. Now we're just going to go to the mean of it and that'll tell us the percent missing in OPS. The data frame has 3.26% missing. I think we go, it was way too big. There we go. The data frame has 3.26% of the data missing. Whoa, we're almost done with this. Using names, sort, and table was kind of weird when we could use which max. Yeah, definitely. Alex, that's a quick way. I totally agree. Alex, 20 points right there. Yep, it's way quicker. There's so many, like, do it the quickest way. I agree sometimes. So this right here is already here for you. We're basically going to do this. Here's some free points. Let's do this. So I'm going to explain briefly about this. So this is in the video now. So question 9, the bonus for it is in the video. I'm just not, I don't think we're going to do this. We'll do this in 474. Is there a way I can clear certain things from my global environment without clearing everything? Yep. Right here, Ben, put it inside of that. So put it inside of the remove right there. So whatever you want to remove, put inside of RM and it'll remove it out. 9A was very simple, 9B, and we're incredibly confusing. Yep. Hopefully, I guess this takes a while. I haven't ran this one in a while. When I did 9A, I used, you got that? I used mean is.na OPS, and I got, that's what I'm using right here is, maybe I'm running a different OPS. Does your guys' OPS, let me see here. The OPS you guys might have is a, wait, OPS. Am I running the wrong OPS data frame? 558 variables. Oh, ha 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 ha. Yeah, no, this is, my OPS is different. Yeah, my OPS is different. So your thing is correct. And this is why my OPS is taking so long. And I might have crashed R. Yeah. Hopefully we didn't lose everything. I have just crashed R. And this is on a really good computer. So ours only has, yep, that's what I was noticing. Mine is a mine's the full OPS it looks like. And your OPS, I think, is loaded in from the, where's the load environment? I think you load in your OPS from that. Where is it? Load in the assignment. Yeah, here it is right here. I'm going to have to straight quit out of R. Do we call it? There's the June 3rd. We got to make sure this is saved. Oh, no, 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 no. Don't break. I know, F in chat. This is a true F in chat right here. Searching for definition. It's like searching for the meaning of life right now. This is Brian crashes R. Brian destroys, oh man. So sad. I'm gonna do it. I'm gonna do it. Wait, unable to. It's fun crashing R. Okay, good. It's for some reason it put it at the end. We saved that. Okay, we're good. And then I should have put. Okay, here we go. Okay, go away code. Gone. Okay, run code right here. No, don't load in those things. Let me go up here and let me remove those installs. So they're hashtagged. Let me go down here to load. Load. No file. Session, set working directory. What am I? I know. You're mad, R. Session, set working directory, choose working directory. Downloads, where I put all the files. And I should have this. Yep. There's OPS. We got that OPS. In before Brian breaks it again. Oh, yeah. No, it's fun breaking R. It's just like, it's break R all the time. That's what we do. We break R in this class. It's what happens. You just have to get used to R just falling apart on you. Oh, look at that right there. We got the answer. So there's the answer right there. Hopefully people aren't freaking out. And wait a minute. Wait a minute. Here we go. It's gonna load. Whoa, we got it right here. Cool. Okay. So let's take a look right here. There's a lot of output in this, but the only thing we're really going to look at is we want to examine the rules. And so right here, let us conduct an analysis of missing patterns of Q2, Q3, Q6, Q7, columns akin to the ones that have been presented. Okay, so this is a big thing I'm going to talk about right here and what all of these mean. So let's grab this output. I'm going to expand it. So if you're in 474 and you happen to show up a little bit early, this is really good for you. We'll not be doing this in 320 because I will cover this in depth in 474. We put this in 320 and then we need the count. Rerun the analysis. Rules, inspect rules, cool. There we go. So I'm about to answer all the bonus. So the answers to the bonus will be in here. Okay. Say, Brian, that's too small. I know. Zoom in on it. Okay. So hopefully everyone can kind of see what's going on right here. Let's talk about what these things mean individually right here. The way this is read right here. So if you're in 474, this is big because you'll be covering this. You'll need to know this in depth, especially for your test. 320, don't worry so much. Given Quan 3 is missing, how does that impact Quan 2 missing? Given Quan 3 is missing, how does that impact Quan 2 missing? So now we look at what the support means. The support means the percent of time that Quan 3 and Quan 2 are both missing. So if you notice, this one says given Quan 2 is missing, how does that impact Quan 3 missing? And so with that, you'll notice if we read what the support is here, it's still the same value because it's still the percent of time Quan 2 and Quan 3 are missing. So then if Quan 6 is missing, so then if you go to the 1, Quan 6, Quan 7, given Quan 6 is missing, how does that impact Quan 7? So this right here for this one, this is the percent of time that both Quan 6 and Quan 7 are missing. So this is the percent of time that both Quan 6 and Quan 7 are missing. Quan 6 and Quan 7 are missing from the data frame 63% of the time in the data frame. And then this right here, the confidence, this means given Quan 6 is missing, Quan 7 will be missing 100% of the time. And they've updated this. I am not joking. They've updated this with something called coverage, which is a new thing that I do not know how to interpret. And I can show you the old output we have in the notes, but there is now something called coverage, and that's why the output was a little bit longer than I'm used to. And I hate to say it, I don't know how to interpret coverage right now, and I'm glad we're looking at this, because when I get to 474, I want to look at it. Coverage is not in the notes for 474, but it's a new thing they've added to the A rules package. This is the A rules package. So I do not know what coverage is. But what does lift mean? I know what lift means, which is kind of the whole point of this. Lift is the major point of what we're trying to analyze right here. Lift means, given Quan 6 is missing, Quan 7 is more likely to be missing by 1.5 times. So what would be a lift that would really show us no relationship? What would be a lift that would show us that like nothing weird is going on right here? What would be a lift that would be not interesting? Because a lift is a ratio of how much more or less likely something is to occur. So if I were to say a lift of 10, something would be 10 times more likely to occur. So in this instance, if this had a lift of 10, given Quan 6 is missing, Quan 7 is 10 times more likely to be missing. Yep, 1. Ryan, 20 points right there. Great answer. A lift of 1 means, given Quan 6 is missing, Quan 7's probability of missing is exactly the same. because the lift is the relative increase. Think about this as like lifting it up by this factor. It's a factor increase. So then the probability of quant 7 missing increases by a factor of 1. I think so. Let me double check. The original probability of yes, and you just got lucky. Don't worry, I know it's for me weird for me to say you got lucky. It's just that quant 6 and quant 7 are missing all the time together. If you look at the data frame, the way this data is structured is that in the OPS data frame, quant 6 and quant 7 are missing. Here's quant 6 and quant 7. They're missing all the time together. Whenever quant 6 is missing, quant 7 is missing. Quant 6 and quant 7 are missing from the data frame. Where's the right answer? Where is it? Why am I? There's 6 and 7. Something's odd about this. Oh, that's given 6 and 7 are missing. How does that impact 2? So this is given quant 6 is missing. How does that impact quant 7? This is the support, which tells us that quant 6 and quant 7 are missing from the data frame together 0.63% of the time. And if you notice, it's just that they are always missing together. And this we here would say, given quant 7 is missing, how does it impact quant 6 is missing? If quant 7 is missing, quant 6 is always missing. Given quant 6 is missing, how does it impact quant 7 missing? If quant 6 is missing, quant 7 is always missing. But you can't always just times it by its lift. This one just has the unique relationship that they're always missing together. And you can see that right here in the data frame. And we can view this data frame and get a good idea of what's going on. For larger data frames, it might be harder. And you see here, there's a pattern here where we have outcome, but we didn't do analysis on outcome. We only did it on the quants because you can make a lot of output for these things. But yeah, does that make more sense, Alex, how to answer this one? I mean, it basically just gave away the answer to it, how lift tells us that if quant 6 is missing, quant 7 will always be missing. That should do it right there. And I'm going to go grab a little bit of my green drink. I'll be right back here. Does that, I think there was one more question on this. What was the last question on it? Let's conduct a missingness pattern. This is in the end of yesterday's video. So if you're watching this still, this question for, what is that? Is that that's not Megalovania. So that's LOP, I think, yeah. And this is in the end of yesterday's video. If you want to do this bonus right here, this is in the end of yesterday's video. So look at yesterday's video, and you'll see this right here. And I'm going to start their class with it also. So if you're in 320, stay tuned. I'll be back here in like 4 minutes, and I'll be explaining how to do the MD pattern again. So stay tuned. Be back soon. Bye. No.
Dimensions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.
Everyone, is Wacky Wednesdays. Wacky Wednesdays as I click a wrong button. But it is Wacky Wednesdays. So good to see everybody. Who knows what's going to happen with the points today. Once again, I love my little crash. Little crash. Wait, he's over here. Wait, there's the big crash. Good to see everybody. Hope you're having a great morning today. Get you guys wide awake. We got a, other class asked for it. We got a little crab rave right here. Getting out the crab rave. Bring the volume up and down. Hopefully I didn't raise it too loud right there. Go a little quieter on the crab rave right here. Just controlling the crab rave volume. Good morning. Waking everyone up. Wah? Wah? Wah. So, you guys cracking up in the chat. Good morning, everybody. So, and if you're here watching this from 320, we're talking a little bit about your bonus. So, you guys are awesome. And thank you guys. Attendance has been really good. And we should have assignments graded up. I want to get assignments graded in about 2 days. I might actually start grading your guys' assignments to help out the grader because they're grading 320 and 474. So expect assignments to start getting graded. My neighbor just knocked on the wall. That's good. So expect assignments to start getting graded, and that's what we got going on right here. So let's start doing this. And continuing on, let's do some missing data right here. Might get interesting for the rest of the semester. So, missing data is very, very important to what we have going on. We can talk about the missing patterns. Who remembers the missing patterns and what we have going on? Let's go right here. Let's hop to the main screen. And with the main screen right here, we were talking about this, the bonus for the last class, and we have the MD patterns. What is going on here with MD patterns? MD patterns is going to show us the missing patterns. Well, let's take a look at it. Does anyone remember from yesterday how to look at this missingness pattern right here? Who knows what is going on? Any ideas what is going on right here? Who can interpret this 277? Who remembers from yesterday what this means for 277? Any ideas? The chat is quiet. Who knows for 277? Well, there's two patterns. You're right. Ahmed, awesome. 20 points, Ahmed, right there. You are totally right that this 277 means that there are there's two patterns here. One pattern here and one pattern here. So we have these two patterns right here. So with these two patterns, what does this 277 mean, though? What does the 277? Ahmed, you're right. Man, great job. So there are 277 rows where Quan 6 is present and Quan 7 is present. There are 277 rows where Quan 6 is present and Quan 7 is present. What does the 474 mean? And what do these red blocks mean? So if you are writing these answers in the chat, you're getting what these missing patterns mean right here. This 474 right here means that there's 474 rows where Quan 6 and Quan 7 are missing. What does the 0 mean right here? Who can explain in words what the 0 means? In these 277 rows, what does the 0 mean right here? In these 277 rows, what does this 0 mean? What does the 0 mean? 0 missing fields. Exactly. This is how many of the data values are missing. There are 0 missing, exactly like Quan 6 and Quan 7. We have a 0 here because neither of them are missing. What does this 2 mean? That there are 2 missing fields. This is how many missing fields there are. What does the 474 mean for the whole data frame? So this 474 right here, this one right here means what for the full data frame? In the full data frame, what? This 474 right here means what? What does that 474 mean right there? What does this 474 mean? It's so funny because we're in 474 and now you got 474. So it'll mean basically, Sarah, 20 points, Sarah, right there. It would mean that we have 474 observations from Q6 that are missing. In Q6, of missing observations. Missing. So Q6 has a total of 474 missing observations from Q6. When you go down this way, 474 missing observations from Q6. This one is 474 missing observations from Q7. No, don't worry. It's the missingness. And then right here, the 948 means total in the data frame. There are 948 missing observations in the full data frame. So, and then, well, no. So we don't know how many are, well, we do know, let's see, these are the 277 rows right here. So it looks like there's 277 rows where Q6 is present. And so you can figure out for this one that there is a total of 277 times when Quan 6 is present because it's these rows where it's present. We can make a more complex missingness pattern right here. Let's do a more complex one. And we have Quan 2 also. So let's go here and go to Quan 2. And now it's a more complex missingness pattern. Oh my gosh. Can we get it so it fits on the screen? We might need to export to PDF. So let's go to rplot2. Sure, let's see if it works. Oh, missing this pattern. You are so bad at making pictures sometimes. I never understand rplot3. What? Export, save as image, rplot4. So rp3. rp3. Here it is, PNG file. It saves it like as it shows it. And this is one issue I have with this package. Now, if you notice, since we have an issue with this graphic right here, we can do it the other way though. So we don't have to use the graphic. We can go right here. Let's put this to this. And let's go back into here. And let's go down a little bit. And if you notice right here, here's the same information. This is the same exact information right here, but it's being split up differently. So let's take this and let's put it to a screenshot right here. Let's do this. Let's grab this. Let's bring it over to here. And let's take a look. So this is the same thing that the graphic is making. And I think they made this output just because a lot of times you can't get it to fit on the screen properly. Quan 2 is missing from the data frame 12 times. Quan 6, as we saw earlier, is missing 474 times. Quan 7 is missing 474 times. There are 4 patterns of missingness. Pattern 1, pattern 2, pattern 3, pattern 4. And what does this mean right here? What does this right here mean for us? Like especially this right here. What does that I've circled right there mean? So there are, I think Adam, that's right, I think. What does that 3 represent right there? What does that 3 represent? Any ideas what the 3? 20 points, who knows what that 3 represents? Who knows what that 3 represents? 3 rows missing, yep, exactly. Yep, and that's what the zeros mean right here, that they're all missing. And then the 3 right here is standing for these all missing right there, that there are 3 things missing. So being able to read across this and be like, okay, there are 3 rows that have all 3 of these missing. And the 3 is there because there's 3 zeros. Just like the 2 is here because there's 2 zeros right there. The 1 is here because there's 1 0 right here. And the 0 is here because there's no zeros there. So understanding what is going on right there is very important to be like, okay, where do we have all of this right here? Where do we have these individual things? So with this right here, let's take a look and let's see what, I think we know what all this means now. What is this right here? This is actually a good one. This is the last one I'll mention, but who feels like they understand what all these numbers mean? Like when you look at this, you can trace down and understand this is for Quan 2, Quan 6, Quan 7. You can trace across. Does anyone feel like they understand? Yep. Adam, you're right. That is rows that have every variable present. We don't have NAs for any of them. And so what is this analyzing? It's analyzing where the NAs are. So this is very important, like a validation, which is what we've been covering, way for looking at our data. Very, 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 very important to understand what is going on right here. I turned my volume up just a little bit since I'm talking a little bit quieter. And so we need to know who feels like they get this. Let's get some yes or no's in the chat. Let me see how people are doing. We're going to do a vote. We're going to do vote yes, vote no. And let's do this right here. Let's do this. We got yes, and we got no. And let's do this. Let's start the poll on this right here. Who feels like they get this? Who feels like they don't? We got vote yes and vote no. Could you go over the columns again? Yep. So the columns right here, as people are voting yes and no, is the column right here like this represents that Quan 2 is missing 12 times in the data frame. Quan 6 is missing 474 times. Quan 7 is missing 474 times. And if you look at where Quan 6 is missing in these patterns. And look, what does that equal up to? If you add up these numbers right here, you'll notice that that is 474. That's what I like to see. I felt like everyone was like, we got this. We understand this. We know what's going on. That's what I like to see. Excellent, excellent work right there. Let's hop back into the notes. So here we are with validation, with missing data. Lucky Wednesday, man. I love it. So awesome. No, thank you for the questions. Anisha right there, 20 points. That's what we like to see. And look, 100%. Gosh, you guys are awesome. Voting in the chat. I love it. Hopefully we only had 15 votes. So hopefully we have more people watching than that, and hopefully everyone's getting it. So predictive models, exploring, so much to explore. The hardest thing, and yeah, let's go back to transformations because we didn't do that yesterday. So I would say the hardest thing in this class is, or just with data in general, is whenever you get data, knowing what to do with the data. I'm working on a project with, I think I told everyone this yesterday. The student is, Andrew should be in here, right? Andrew, you here today? So I'm working with, he said he wasn't in the office when the student showed up, but this was awesome, Andrew. Yeah, so I did start, I think. This student was a high school student. I told about him yesterday. He started working with us at UT on some stock data, and literally you have to learn about the data as you go. And the experience that he's getting, I told him, you're getting as good as some of my students, because he's having to like ask questions and be like, well, what do we do here now? How do we do this? What code should I do? And he's looking up code. And I'm just really impressed that he's going into his senior year in high school, he's learning all of these things and like having to do it on his own. And I told him, you're getting a lot of good experience. I know it's like a lot of people say, like, you're getting a lot of good experience, but he's really learning what's going on with the world of data. And the hardest thing is, what do you do with data? When you get data, what do you do? How do you clean the data? How do you analyze the data? Data does not come with instructions on how to run it. So when we look at things like transformations right here, this is a hard topic because transformations are like, who knows? You could transform your data any which way. So let's talk about it. So when we get data right here, we usually want our data to look pretty normal. So we want, a lot of our statistical techniques are going to work on normal data. And I'm saying normal, but that basically means unimodal symmetric. So when you look at normal looking data, we're talking unimodal symmetric data. We don't want a crazy right skew distribution. We want data that looks mainly normal. And I think we might show some pictures of it here coming up in a second. But here we go. So the data set on the left is going to be a very problematic data set. This right here, not going to analyze well. This right here will analyze better. And it's because the variation in the data set over here is mainly coming from extreme values. And so these extreme values will kind of dictate the analysis. If you were to run the mean's going to be inflated. If you were to do the range of it, the range is going to be very large. But meanwhile, most of the data is inside of here. But you can do a transformation. This one I think is the log. Yeah, log 10. Log 10ing the data does something interesting. Values that are at 1 were originally at what? Who knows for 20 points in the chat? Values of 1 were originally at a value of what when we log 10 them? So what's over here is 1, and this is a very, I might put this as a test question. Close. No one's got it yet. I'll put R here in the chat. We need to open up a new file. No one's got it. Oops, no, wait. There, Nitin got it right there. You're right. There you go. Because it's what power do you raise 10 to get 10? So right here we see that 10 raised to the first power is 10. 10 raised to the second power is 100. So we see right here that we've obtained the log and we can see what's going on. So awesome stuff right there. We know what's going on. And with this right here, we have all these values around 10. Here's where 10 would about be at. So if you think where 10 would be at, it'd be in here. And then if you look at where the peak of the distribution is over here, it's around 1, because that's where all these values were here. Now you have almost a value over here at about 2, because maybe there's a bin we can't see. I don't know. It's like maybe there is a data point in donor amount. Wait, can I see it? Oh my gosh. There it is right there. That bin right there. You might not be able to see it. Now you can see it. And there's actually other bins. Oh, wait, there's another bin right there. Holy mackerel. That was so hard to see when you zoom out. Now I'm going to lose my... Oh, good. It zoomed back out right. But you can't see it from here, but you can see it over here. And there's... Oh, and I guess there is little data over here because it's extending the axis. So that's the data we could barely see over here. Like it's purposely putting the scale out this long because there is data out here. So it's logging, kind of pulling in those data sets over there. It's pulling in that data. Very, very important. So when do we consider log transformations? When we have really skewed data. So the log transformation, probably the biggest note you could take, and maybe a lot of you knew this, but when you have extremely skewed data, highly, highly skewed data, left or right, it's usually right skew because there's usually a far out, you can go far, far out on it. When you have right skewed data, that is when we would consider a log transformation. So does log 10 work well to normalize left skew data? I bet it would too. Let me think right here. Yeah, it should, because it'll pull in all values. It'll pull everything together, and we should be able to make... Here, we can make a left skew data set. I like that right there. That's 100 points toss right there. Making me think. So let's go here to data, and let's go to 1, 1, 1, 1, 1. That's going to be right skew if I do that. 1, 2, no, 1, 5, 10. Let's go to 50. Let's go to 100. 200, 450, 455, and then rep 460 10 times. Okay. Can't find data. Nope. C, concatenate. Okay, there we go. And so this should be a right skew data frame now. I mean left skew. Excuse me, left skew, because you want left skew. We're going to call this data, which is what I meant to do right here. So we're creating a left skew data frame. Let's confirm. And that's a very, 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 very left skew. I don't like the way that looks right there. Let's change. So that's the rep we did right there. I don't want so many data things right there. I want this to be 300. Let's see, 350, 300, 200, 100, and 1. There we go. So here is a left skew data set. And then we're going to we're going to do a histogram again of it. And we're just going to go here and log 10 it. And we're going to see if it looks a good bit more normal now. Ooh. That looks way worse, actually. Maybe it's just due to the bins. The scale's a lot smaller. But you know what we can do? We could try something else right here. We could scale it. And this might work. So let's try the scale of the data. That doesn't work either. It's due to all those extreme values. So we're having a hard time normalizing this data. So this data set right here is not getting normalized very well. It is on a smaller scale. We do have these negative z-scores, but I tried, we can look at the two different ones right here. We got this, here's the log 10. We could try scale of log 10. We'll try double adjusting it. Still, this is some very hard to normalize data. And if you look at the data, it's just a very, very odd data set. And so that's the graphical error. But look at the data set. It's very, very, like all these repeat values, I think, are having a problem with it. And so not normalizing very well. Toss, well-earned 100 points. This is why, once again, your data dictates what you do. How could we report the data after transforming it? So Amit, amazing question too. So the biggest thing is, what are we doing with the analysis? Are we just trying to make like an R squared? If we're just trying to make an R squared, we don't need to transform back. If we are trying to like tell people what to increase or decrease, we would need to untransform the variable. So usually it depends on like the analysis once again. If the analysis is just to obtain like the percent of variation explained by this and we do a transformation, so we could say like this variable transformed explains this percent of the variation. And sometimes we call this like, like a model that you don't get to see what's really going on inside of it. And you kind of input all these things and then it outputs like this answer right here. So you could collect a bunch of variables, you could transform them and then output an answer. So imagine a baseball association and they want to predict if a player will be successful in the majors. So they collect on like what's their batting average, how fast do they run, what's all these different statistics, and then they maybe transform them and they do all these equations and then it outputs a prediction. So the y variable is usually the one we care about. Take this huge note. I want to see this for 20 points in chat. The y variable is the one we usually untransform. Like the y variable is the one you want in untransformed units. So if we ever talk about untransforming an equation, which we do sometimes, usually we untransform for the y. The y variable is the one we want to get in untransformed units. Because I wouldn't want to say like the log 10 of wins. I'd want to know how many wins we expect a team to get, not the log 10 of wins. Because if I'm like, oh, the log 10 of wins is 1, you'd be like, what is that? I'd be like, oh, it means 10. Like, well, why don't you just tell me you expect 10 wins? So usually put in the chat, the y variable, yes, Madeline and Caroline, 20 points right there. The y variable is the one we usually untransform. That's very important right there, that the y variable is the one that we untransform. You got it. That is what we do. Let's do this. So propieness of adding a constant. Yeah, you could do this right here. And maybe, you know what? We're going to try all these different things right here. Let's try log 10 of it. Too large. Wait. No, we don't do that. We're going to go here. It's looking better. It's still got the problem that these are just so far out there. I mean, it's on a smaller scale right now. That's good, but see, the thing is now this became 2 and this went up here. It's just that you're never going to make this bump go away. This bump will never go away because that's the repeated value. So because of the repeated value, you can see right here of the 460 that I created, that bump will never go away. So I guess we could try this, a sequence going from 455 to 465, and we could do length. I guess we'll still see that. Length equals 12. And now let's try this. Still looks like that. Let's look at this one. Yeah, they're all so close. This is very, very, very messy data. And maybe if we had more values in here, they would start to bunch up. But there's so few values. And sometimes you get a data set you can't fix. Data's tough. That's what we get. Data's tough to work with. To unlog values, you'll raise it to the power. So when you look at this right here, this is very important. Knowing how to unlog stuff is so important. I remember when I first had to do this and I was very confused, like, how do I unlog stuff? Well, if we get 3 and this was log 10, what does that equal? If this was log 10 and we get 3 for 20 points, what does that equal? What is 3 untransformed after it's been log 10? Boom. Ahmed, 20 points. You got it. And Yaoji right there also 20 points. You guys got it. So we can do this. Log 10 of this equals 3. Graphical error. So there we go right there. And 10 raised to the 3rd. That's the unlogging of it. So this is logging. This is unlogging. So that is how we do it right there, logging it and unlogging it. Very, very important to know how to do this. Very, very important. So you can see how to unlog it, just raise it to the power of whatever it was. This is the base right here. We're raising 10 to the power of this, but tell me this. What would I do to unlog this? What do I do to unlog that? Who can tell me 100 points on these wacky Wednesdays? Who can tell me how to undo this one? Big review question right here. We are breaking the rules of getting 60 points. Who can tell me how to undo this one? I have tricked everyone. I put no base in here. How do we undo this one? Nope. No one knows yet. Yes, Ahmed right there. Ahmed, you are right. Ahmed is right. Because the default, and it's just rounding. It's rounding. There. Oh, see, look, there's your extra decimal we can almost figure out. Oh my gosh, it's like seriously this small. There we go. There was like an extra decimal. Yep. It's E raised to it. 20 points, everyone else. Yes, following along. That the default for log is E. Log uses, there we go. Nice job right there. And then 20 points. And then, so the default for log is E. It uses E as the default base. Very important note right there that log uses default base E. We should know this. Or exp is the function, but we should know that it's E. And then we would raise E to it, just like the notes say right here, to unlog stuff. We simply use the base and then raise whatever it was logged to by that base. Very important to know how to unlog stuff. It's pretty simple, but I think we forget it a lot of times. And then we have right here, this is classic. Oh my gosh. 100 points. You know I'm going to do it again. Wacky Wednesdays. So 100 points right here. Who knows what this basically is? Who knows what this is right here? This is basically a what? Because it's the observation minus the mean over the standard deviation. What are we basically making right here with the new variable we're creating? With the new standardization of it, it's observation minus mean over standard deviation. Z-score toss. My gosh, you're just racking up the points. You got it, man. That's you can only get up to 60 points. And so what is a Z-score? It's a different, I mean, you can get more than 60 if I give you the crazy wacky Wednesday points, which you've gotten twice now. Wow. It is a Z-score. Because everyone else is getting 20 points and they're getting their max 60. But we'll throw out some more wacky Wednesday points. Don't worry. There's more opportunities. So we have right here that we're taking the original value minus the mean. So we're getting a difference. And then we are standardizing that difference. That is the key right here, that we're taking a difference and we are standardizing that difference. So this creates a z-score, which we're just calling the new variable. It's a new way to talk about it based on the new scaling right here. So we are creating a z-score. So that's what we got going on right here. We understand this. There's other ways to scale stuff. You could put it on a literal scale, which cool. Right here you can scale between 0 and 1, or you can scale between other values. Look at this right here. The max minus the min would be the range. So all this is the range, and then we just take right here the original value, the old value it was, and subtract from the min. So if this was the min, min minus min would be what? Min minus min would be what? The lowest value, when you put it in here, will become what? If you put the minimum in here, it will be min minus min. That'll become what? So you can kind of see how it works. Like, oh, it'll be min minus min. It'll be 0. Paid 20 points right there. It'll be 0, and then 0 over the range is 0. So then you'll get 0. If you were to take the max, max minus min is the range. And you get range over range, which is 1. So all you're doing is scaling this, and it's the new scale we're putting it to. And it'll go to a 0, 1 scale. So I could do this to my variable, but it's still going to create the structure we see. It's just got everything like all up on the one side of it. Scaling in R. Oh, it's so easy. If you notice, I already used this function right here. Oh, is it not on the slide? There it is. There's scale. So what does the scale function do? I ran it earlier. Scale literally takes something and turns everything in it into z-scores. Just like that. So you can see right here that when I scale it, every single value becomes a z-score. And because it's got such a strong left skew, you can see that these are pretty much outliers right here. Light outliers because they're at -2. A real outlier would be at -3. They're not real outliers. So we see right here that we have some kind of values towards the mean of the data set. And you could debate, should we be using mean? Because this is very, very skewed data. I wonder, how do the z-scores look when we log 10 it? So I'm going to look at the log 10 z-scores. If you notice, these get closer to 0, and it's really this one outlier right here. So if we didn't have that one outlier, which we could remove it, which that's the first data point, we might get, now the other one's an outlier. If we did not have these two outliers, you might explain what a z-score is. No, that's Sarah. Great question. 20 points, Sarah. Great question. So when we do a z-score, let's hop over here. Oh, let's see here. Yeah, we'll hop over to the other screen. Let's do it. So a z-score is a standardized difference. So when we talk about what a z-score is, a z-score is going to be the observation minus the mean over the standard deviation. And that's what a z-score is. But let's talk about this. Brian is 6'3", which is 75 inches tall. Is that the mean, the standard deviation, or observation? Brian is 6'3". What is that in terms of what I've written up there? Brian is 6'3". So what is that? That's the observation. That's what we observe Brian being for a height. But now we need to know the what for guys. We need to compare Brian to the what for guys. We'll compare Brian to the mean for guys to look at his difference from the mean. So the mean for guys is 69 inches. And then we need to know the standard deviation, which is the variation. The mean is the center of the curve. So the mean is right here. That's the mean. And then the standard deviation is the variation. So the standard deviation is like how far spread out the curve is. So standard deviation controls how spread out it is, and the mean controls where the center of the curve is. And then we go here, we write 3 on the bottom. And then what is Brian's z-score? What would Brian's z-score be? What would Brian's z-score be? It'd be 2. And then let's think about what this means. Brian's height is 2 standard deviations above the mean. So a z-score is a standardized metric that tells us how many standard deviations something is above or below the mean. So something with a z-score of 0 would be at where? Where would a z-score of 0 be at? 20 points, all these answers. Great job. Where would a z-score of 0 be? A z-score of 0 would have to be directly where? On the mean. It'd have to be on the mean, so in the middle. Exactly, it'd be on the mean. So if you notice right here, a z-score of 0 would mean something was observed right on the mean. And then negative z-scores mean they're below the mean, and positive z-scores mean they're above the mean. So understanding what a z-score is, and don't worry, it's a great question because it's something we do in 201. We don't do it that much in 320, but z-scores are very important for this class. We'll use them multiple times. A z-score is just a standardized unit of measurement for how far something is above or below the mean. A z-score is a standardized unit of measurement for how far an observation is above or below the mean. Great question right there. Thank you for asking. Over here. Oh no, wrong slide. Oh no, wrong thing. Yay, we got it. So here we are. We've got everything going on right here. Missing data. Missing data. We are back to missing data. So we see right here, NA remove equals true needs to be used for some functions. We have functions right here where we have to do NA remove equals true because I don't know why they did this when they wrote these functions. I think they want you to know that you have missing data. And if you see right here that you get an NA, that means when you run mean, there is missing data. So when you run the mean of X, there was missing data inside of here. So it reports NA for you, saying to you, there's nothing to report missingness. But it kind of just means that there's missingness in your data. So we see that right there. What do? NA remove equals true. NA remove equals true will remove the NAs and then report for you the mean without the NAs. Now, you have to watch out because with logicals and stuff like this can create small variation within answers, and it's just weird things you'll see. There's so many things I could tell you that I've seen with data that I could just, I can go on so many tangents. But what do I mean by that? If it can't run a logical check, it'll report NA. And then how do we handle those NAs? I would almost turn those NAs to false. I don't know. Man, I wish Dr. Petrie was here. Dr. Petrie, where are you at? Because it's like, it's not, it is not this. If it's NA, then it isn't this. But then there's nothing to report. So can we say it's not that? I don't know. Then you get into questions. But you might just report the NAs and say, like, there were this many NAs, which it will report in summary. When building a predictive model, even a relatively bad guess for a missing value is better than no guess. Yep. So you'll see a lot of times we'll store into missing values, we'll store like the median value. So this is what we can do to handle missing values. So there's a really big thing. And man, now I miss Dr. Seaver. So Dr. Seaver, oh man, we got to pay some respect to Dr. Seaver. Let's help over to the main screen. I want to see Dr. Seaver. He's going to make me smile this morning. Dr. Seaver, UTK. Dr. Seaver is one of my kind of, I would say, mentors. He'd probably laugh at that. So it's taking a while to load his page right here. But Dr. Seaver, such an amazing guy. Very, very... Oh, there's his picture right there. I should just click on that picture. Here we go. Here's Dr. William Bill Seaver. Oh, I should talk to him about Texas. I should talk to him about Texas. Oh, yeah, we have some amazing people in our department. I'll show that off in a second. But Dr. Seaver, he got Texas A&M. Is that where we're going? Wait a minute. That's where we're going. I should talk to him about Texas A&M. Be like, hey, Dr. Seaver, I'm heading down to Texas A&M. He'll be like, he'll probably say, oh, no, I feel bad for them. He'll give me a hard time a lot of times just for fun. And he is, he's now retired, but he does a lot of consulting. So, yeah, he'll always laugh at me, and I love it. He's basically, he's like almost exactly my dad's age. But he's such a great guy, and he and I, we differ on a lot of our views, but that's why it's fun to talk to him. Like, it's fun to, let's go here to BAS faculty. Let's go here to UTK, BAS faculty. This should pull up our page, right? Yes. Just so you can see some of the faculty in the business analytics. He is teaching the time series course. Awesome. Oh, you guys are awesome, Devin. I don't know why these pages take a while. Come on, UT, what's up? There's Dr. Galbraith, amazing guy. He's our new department head, and he's been our department head for like 2 years now. Absolutely amazing. I mean, I could speak to everyone. Humphreys Bosdogan, Bowers, Bogdan, Dr. Ballings. I don't know, some people. There's Jerry Day. Awesome. Charlie Quick. So, oh, Devin. I totally didn't see your name, Devin. So good to see you, Devin. Devin was in mini-term. Thank you, Devin. We're just talking about people who teach courses in our department right now. Devin, so good to see you. No, I know, Devin. I read the comment and I didn't see the name. Devin, so much thank you for swinging by. You get to hear some craziness here in a moment. Dr. Lee, Dr. Lou, and then I don't know this gentleman. You're cracking me up, Devin. It's funny that I don't know somebody. It says like they're adjunct. I don't even know what that means. And this gentleman here, I don't know either. But there's Dr. Panel, Dr. Petrie. He's on promotion for senior lecturer right now, well deserved. And just there's me. Here's Dr. Sean Willems. Talk about not saying other people are not smart, but he's the Haslam Chair in Supply Chain Analytics, and he also works at, I think, Boston College right now. So he works at Boston College. Swing by anytime, Devin. He's in the math department. He is. I should go say hey to him. Is it this gentleman? And this gentleman, I don't know who they are. I don't know them. I've never met them in my life. Maybe I have, and I just don't remember. Dr. Winjun, and I know everyone, but it's just so many people. Like, I've worked for so long. Highlob's awesome. I mean, not that anyone's not awesome. Julie Ferrer, assistant department head, but this is our department right here. Lots of great people, and it's really sad to me. I don't know Chris Groyer. I don't know him, but we've had a lot of people retire recently, and then it makes me miss more and more people. Missy Morris, I was going to say Dr. Missy Morris. She's great. We've worked together so long, and she helps so much. Dr. Zareski. Anyways, lots of great people in our department, lots of different experiences, lots of different backgrounds, and they all really care about students. I think that's one of the best things about the business analytics department is our department is very, very student focused. And maybe you've experienced that by, we are like, it's all about students. Like Dr. Bowers, like she helped me so much when I was in the master's program. So thank you so much to all the people, because I've gone through the master's program. So going back. So once again, we have everything right here, building our predictive models, fitting our models. So when we look at the missingness in data, we can actually see where the missingness is at in certain columns. Yep, Julie Ferrer, and she's excellent. I actually took that class with her in grad school. So I took the marketing analytics, which you get Google. I don't know if you still get Google AdWords certified, but it taught me a lot about web analytics. So excellent course with Julie Ferrer. It's a lot of fun, and you get to work with a local company. I hope everything's still working good on that, and you get to help them with their Google AdWords campaign. So it's like actual hands-on experience. You can be like, oh, I worked with such and such company on their AdWords campaign, and we were able to make these changes and do this. It's like pure resume stuff, and it's pure skills. So 370, amazing class. I could tell you, it's like there's either classes I love in our department or classes I like. Not that I don't dislike any of our classes. I'm in the department, but I'm being honest that there's some classes that some classes I want to take again, or classes I should just take. And maybe, a class I might take is I might try, if I have time, to sit in on time series, because I know time series, but I don't know it well enough. Like, if you do time series with Dr. Seaver and you come out of that with an A, your knowledge of time series is probably better than Brian Stevens' current knowledge of time series. I just haven't done time series stuff in a decade. So think of something you did a decade ago and be like, okay, I took this, or I did this, I did, American history a decade ago, and be like, how well do I know that? And I just don't use it. I think it's 475, right? And time series is very important too. And I want to start teaching that class eventually. So I need to start sitting in on it. I need to get my knowledge back up on it, because that's one thing our department does. And the way Dr. Seaver teaches it, he uses SPSS. You're 14 a decade ago. I love that. Dr. Seaver, I think, uses SPSS, and Dr. Lee uses R. So there's a difference right there. When Dr. Lee teaches time series, she uses R, but I think Dr. Seaver will accept R. So I'm not saying to use R, but I'm just saying there's a forecast package in R. So you can go here and download the forecast package. Watch this. We're going to go here to install.packages, forecast. If I knew how to spell forecast. Is that right? Let's find out the hard way. Yep, that's the forecast package. So the forecast package inside of R, and you know what I bet? I bet you somebody has made ggplots with this, and I bet you could really impress Dr. Seaver, and maybe we'll win him over to this whole R thing. Okay, everything looks to be good. We're going back for 2 seconds here, because I'm pretty certain someone's had to have made ggplot. ggplot forecast. Yes. It looks like it's showing up. Yep. That looks good. Yeah, these are all right so far. Yeah, they're pretty good. They're cool. Yeah, so people already have all the ggplots and everything you can make. So it wouldn't be that hard. Let me pull back up the screen here. It wouldn't be that hard to actually make your forecasts. And if you look at this, you can see where the series ends. Like, obviously, current world event of one of the reasons, we're like, just, I hope the numbers keep going down. I will say this pattern right here, we have to talk about these things in statistics. We have to mention this. So trigger warning of sorts, about to talk about current world sickness event. Because when I see that pattern you just saw, it's literally, notice this is classic time series. Like what you have in this data right now, this is classic time series. The ggplot example you're looking at right here, this is just an example they're showing you with this wavy pattern right here. And it doesn't really have a linear pattern. It just has like a sinusoidal, like a sine wave pattern through the data. But you see this in data all the time. You can see the 7-day lag in this pattern. And one of my favorite sites, it should be down here. I've clicked on it. There it is right here. Goes through and actually lets you put in the time series pattern on it. So you can get a 7-day lag and you can get the 3-day lag. So is that the 3-day lag? And here's the 7-day lag. So you can kind of get a smoothing out pattern on it. And what does make me a little bit worried is if you look at this, we've leveled off in our new daily cases. And I don't know if it's going back up, but I will say this, it doesn't look to be going down as much. I don't mean to make anyone afraid, but it's numbers, and there's the 7-day smoothing average through it, a moving average. So you'll talk about things in time series like moving average. And time series pattern is when we talk about a time-ordered data set. So this is a very specific analysis, which is you have to know how to handle time-ordered data. So time series analysis is for time-ordered data. So whenever you're doing a time series analysis, it has to be data that was collected in time intervals. So if you notice here, the x-axis is time. So this is a time series analysis. Yeah, but there's a lag then, Ahmed, because the lag is going to be 2 to 14 days on when infection occurs to when symptoms occur. And then there might be a 4 to 20 day lag on diagnosis. Like, think about this. If you get COVID, demonetized on YouTube now. Not that these videos are not monetized anyways. But if you get COVID, you get symptoms on, let's say, day 2. Like the earliest you would see symptoms about day 2. And then you're maybe thinking on day 2, I'm not so bad. Day 3, you're feeling a little bit worse. And day 4, you go to the doctor because you're like, this is not something that's shaken off. I need to get this checked out. So if you go to the doctor on day 4, then we're seeing a 4-day lag. And that's the minimum lag on like point of infection to point of diagnosis. So probably the average is about 7 days. So if you were to go back here 7 days, like this upswing we're seeing right here is from things that happened 7 days ago. So, you have to think to the end of June, we're in June right now. I'm losing track of time. What month comes before? March, April, May, June, the end of May. Whatever's ever happening at the end of May is more likely the impact of this. Like the last week of May is probably the diagnoses we're seeing now. Like last week of May is what we're seeing now. Does that make sense to everybody? And that's why we try to think and understand what's going on in the data. Whatever's happening now, we will see 7 to 10 days from now, I would say. Like the impact of our choices today will show up in the data 7 to 10 days from now. And I'm not saying good or bad or anything like that. I'm just saying data. All I look at here is data. All I'm saying is here's what the data shows. And so, yeah, it's pretty, I don't know, lots. I'm always looking at this data. I look at it every day. So, and this is something important, is we have to have all these tools in our tool set. And truthfully, this is why I keep saying I need to take time series, and I've been saying that for like the last 2 years. One, because I want to teach it. It'd be a great course to be able to teach and have the utmost knowledge in, because every course I teach, I have to learn inside and out. When I started teaching this course, I first was a grader for Dr. Petrie. I sat in the class when I did that. And no, one semester I sat in the course. Then I was a grader while I sat in the course. And then I taught the course. And then it was like a year from that, I became the coordinator of the course. So it took multiple semesters. And I was already teaching 320, but then they were like, we want you to teach 474. You're going to sit in on the class. And then I started grading for the class and like a next semester. And then I started teaching the class. And then Dr. Petrie went on to do higher things because they're like, okay, we've freed up Dr. Petrie now to teach upper level courses because Brian can handle this course. And that's what will happen probably with time series if I do what I want to do of sitting in on the course and then maybe grading and helping out the course. And you get this absolute knowledge of it because then you understand everything. So that's the goal. Learn more, keep learning. So we see right here, we're looking at the NAs, and we've got some pretty important codes right here. There's a lot of ways. I'm going to grab this data set right here. This is pretty crazy what I'm about to do. I'm about to show you a trick I've been using a lot lately. Please take a note of this. This is probably one of the most complicated things I'm going to show you today. And I want to show you something that I like to do. What is lapply? Lapply takes a function and applies it across a list. So you can see right here, we want to get the sum of the NAs, but we don't want to do it for just one column. We want to do it for the whole data set. And the lapply originally puts it out as a list. So here it is, a list. And if you use the unlist, it'll unlist those and put it just as a vector. So then we could save this just as missingness or something. So this is now going to be just saved into missingness. So if I call missingness that, this code right here, which seems pretty complicated, just needs to be broken down. Let's try lapply with something different with the empty cars data frame. So whatever I put, let me show it again. Whatever I put for X, does this make sense? Whatever I put for X, show me X again. whatever I put for x, well, now it's showing the list. X is going to be the list, and whatever I put here will have the function across it. 20 points. What function do you want me to run on the empty cars data frame right here? What function do you want me to run on the empty cars data frame? Who has a function they want me to run on the empty cars data frame? What function would you like me to run? 20 points, who knows? Any function you want me to run on the empty cars data frame. I see no functions. No. Well, sure, let's do that. This right here should return all zeros. It returns false, 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 false. Let's go right here. I think we could do, let's try this. So you might have to do what they're doing right there. So what we do up here is this is a really quick way to write a function. I should start using this format. So this right here is making a custom function where the input is x, and then it's going to put x inside of here. So this makes a custom function. So you could literally go outside of here and say custom function and store into custom function this. And then for the function, you could just call custom function. And wait a minute, incorrect symbol in lapply. Is it open, 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 close? We're missing a close, I think. Good, that's the close we're missing. There we go. So we're missing a close. What does unlist do? So what lapply does, big note here, get ready to take this down. Lapply takes a list and returns a list. So this is a list. Think of a list as a folder, where the first thing in this folder is miles per gallon. The next thing in this folder is CYL for cylinders. So you could go here and go to list, and you could put into this list right here. You could put a list into it with, let's say, empty cars for, and the vector Brian and Darren. So Darren's going to be normal looking Darren. So now this list right here has these things in it. It has for item 2, 4, and you can see right there. It has for 3, Brian and Darren. That's the third thing in the list. But look, it's a vector in the list. This is kind of a number, kind of a length 1 vector. And then the first thing in the list is a data frame. And calling positions in lists is a bit odd because you have to go to list, element 1, and I want column 1. So if you look, this is column 1, but this right here is just empty cars. And so what lapply does, the key thing about lapply is it takes a list, like this list I just built, and what does it do? It applies the function across the list. So does everyone see? It did a summary of the data frame right here. It did a summary of this. Then it did a summary of this. Then it did a summary of this. So what does lapply do? It applies a function to a list across everything in a list. Does that make sense? lapply applies the function you choose to everything in the list. Does that make sense right there? Yes, that's what I like to see. Oh, it is so useful. And there's tapply and sapply and apply, and there might be even dapply. Is there dapply? But there's dapply. No, there's no dapply. There's tapply. Show me tapply. There's tapply. There's sapply, which is like the smart thing. Is there mapply? Yeah, there's. Now I miss Kenny. Kenny would talk. He says it's not mapply. It's maply, dapply, tapply, sapply, apply. He would call it. Yeah, he would call it lapply, dapply, lapply, maply, sapply. Look, it's sapply. He'd say no, it's sapply. He'd be like, let's use sapply on this. I'd be like, sapply. I'd be like, no, sapply. And I'd be like, Kenny. sapply is a smart one that it returns a smart object. So you could, we could try, and what happens when we turn sapply here, it returns the same thing. Sapply is smart apply, and I wish I understood a little bit more how smart apply worked. I should look into it, but I know it tries to evaluate what the object is. So smart apply is like a smart evaluation that takes an object and applies it for the correct way that it should be applied. So it's called like smart apply. And you can always read up more if you want by going to !sapply. Not that. We don't want the brackets. And reading up, is it called smart apply? And they're showing you the different ones. User friendly. So you see here's the different ones right here. V apply. Is it vector apply? I haven't used V apply. Lapply, sapply, vapply, replicate, different things right there. Good stuff. Also, when is it necessary to have function X before you do this? Yes. So, Toss, great question. Line 18, what if I don't specify the list and only the data set? So, right here, so here's the really, and so I'll answer Anish's first. The lapply can be used on a data frame. So, lapply can be used on a data frame. Did everyone hear that? lapply can be used on a data frame. So, you can go here to empty cars and get a summary of everything in empty cars like that, or you could go and do a mean of everything in empty cars. So that's a mean of every column because it's treating the data frame as a list. Now lapply is kind of, oh, that's sapply. sapply, you're so smart. So that's, oh, and you know what sapply did? sapply unlisted these for me. So the smart apply, I don't have to unlist it. Just playing around with functions and seeing what happens. But I could, with lapply, people were asking about unlist earlier, and what does unlist do? Unlist them, and look. The sapply by itself knew to return this as a vector for me because it was like, you probably want this as a vector. But the lapply takes a list and returns a list, so I had to unlist that list to turn it into a vector. So what does unlist do? It takes things out of a list and just puts them into a vector. So if we don't use the unlist, we will get the following. When you think you have to sneeze, you don't sneeze. So it looks at the data column. Yes, it treats every column in the data frame as a, where's our lapply? It treats every column, and here's the unlist version of it. It treats every column in the data frame as an element of a list. Anisha, 20 points again. That's exactly what it's doing. Does that make sense? It treats every column as its own element of a list. So it's like this is the first thing in the list, second thing. I don't like it. I may be weird. I don't mind sneezing. I think sneezing is okay. I mean, I don't want to sneeze in public, but I mean, I don't know. Maybe I don't want to sneeze in my apartment, especially when I'm living with Chelsea. So maybe that'll be bad. I'll stop then. I'll never sneeze again. Like, I'm done sneezing. That's the old Brian. He sneezed. I feel like I have to sneeze again. The other thing we mentioned here is the custom function, and this is very important. So this right here, this function building, because this only takes, like, let's say our data frame had NAs. The problem is I can't go here to this, and I can't do na.remove equals true inside of here. So I can't do this. That'll get mad at me. So do you know what you have to do? You have to go here to something like sum, and you would have to remove it here. So we can make our own custom function. We go to function, and I think this should work. Mean, and let's do mean of x, lowercase x, na.remove equals true. And now we've got our custom function here, and this will just take the mean again, but we are now removing the NAs, and this is our custom function. It's going to return the same thing, but if you want to remove the NAs, you literally have to create your own custom function. And I know it sounds crazy, but this thing right here is, I don't know how to like show it more, but this thing right here is turning this into its own function that takes X. This is the quick way to make a function. I don't usually use this way. I'll show you the way I usually do. And you're learning something more advanced right now, which we'll be covering in the next few days. The usual way, if I were to make this custom function, I'd start by writing fun. And now we're making a function. I want to call it custom function that takes X. And this right here. This will write the exact same thing. These lines of code on line 18 and 20 are identical. It's just that this is kind of the shorthand for writing a function. And it declares function X right here. And then we have everything right next to it right there. I think that space might harm it, is what's going on inside of there. I'd only use this for short functions. The only time I'd use this is if I'm writing a really quick function. And truthfully, I don't use this as much. I was trained to do it this way because you might write a very long function. If you take a look at the things in reg class, like visualize model, I think I had to reboot. If we go here to reg class and we go to visualize model, imagine visualize model being written out without it being inside of a function. So this here, visualize model, we'll clear this and then we'll take a look at it. This is being written with the inputs right here where we have function And then we have the start of the function with the inputs right here. So here's your start of it, just like this here is my start of it right here. So that's the start of the function right there. I couldn't imagine doing it the other way. So I usually kind of say everything inside of here is the function. So this is the whole function for reg class right here. Imagine it being on like a line being stored into something. That'd be insanity. So lots of good stuff going on right there. Lots of good stuff. Exploring the extent of the missingness with summary. Cool. Yep. We now handle that. Complete cases. I literally just used this yesterday. So what does complete cases do? Complete cases is a code that only returns the complete cases. So let's take a look at survey 11. So here we'll put library, reg class, load it up. I feel like something crazy happened. And then we'll go here to data, survey 11. How's everyone doing this morning? Tell me how you're doing in the chat. I haven't talked to you guys nearly enough today. How's everyone doing in the chat? I want to see how you're doing this morning. 20 points, you tell me how you're doing. How is your day going? How are you guys doing? What's going on in the world today? Pretty all right, Adam? I like hearing that. Tired? No, Andrew. Andrew, feel better, man. I'm sorry to hear that. And I don't mind. You can always tell me if you're feeling terrible. But I want you to feel better, man. That is a bummer when you feel bad. But I don't mind, because we should always tell each other how we feel. We should be like, I'm feeling blah. No, we don't want that. We don't want that, but it's honest. We are great. Ahmed, you're awesome, man. That's awesome. I like that right there. You can still say I'm feeling terrible, but it's Wacky Wednesdays. I'm doing pretty good. Just wondering if my neighbor's going to keep, like, I'm just waiting to hear, like, and I'll be like, what can I do? I teach classes, and I've been doing it for a month, and I haven't had, till this morning, issues. Just like, am I going to have issues for the remaining month? Do I need to talk to the office? Okay. Brian's good. Brian's good. Okay. Let's go here and take a look. What does complete cases do? I feel like you need a Pac-Man thing. No, at the very start of class, there was like a bang, bang, bang on the wall. But, you know, I start teaching at 8 a.m., so it's like I've been talking all morning, so I don't know. I mean, what else can I do? And I have to talk. So, and I've been doing this for more than a month, but I've been teaching in the morning. No, that's like that just calls a war. You'll just hear all morning, like I'll be teaching, you'll just hear like the war of like this. Probably. Let's go here. Let's do survey 11. Complete cases right here. Okay, so what this does, I want you guys to think about what this code does right here. I about drove myself mad yesterday. I was helping out the student. Like this free education. Sorry, there was a lot of weird noises there. Sorry. I heard some expletives and weird noises. So, anyways. Okay. Interesting morning. So, what we have going on right here, take a look at this code. This code right here, I'm going to call this subset. What is the difference between the subset and the survey 11? What is the difference between the subset and the survey 11? Does anyone know what the difference between the subset and the survey 11 is? Take a look at this and take a look at this code. This is in the what space of the code. This is in the what space of the code. This is in the what space. The rows. Connor. What up, Connor? Good to see you here, Connor. Connor gets 1,000,000 points. This is in the row space of the code. And so since this is in the row space, this is a vector of trues and falses that tells us if something is a complete case. And what does a complete case? What's up, my dude? See, he's here to brighten your day. So we have, this is whether or not the row is a complete case. When you run complete cases, it always checks the rows. So this will only return the rows that are complete cases. So you see right here, survey 11, we're going inside of it, and we're only returning the complete cases for the rows right here. So this only returns the complete cases for the rows. All of this good stuff. right here, right now, being stored into sub right there. So all of this good stuff right here. Continuing on, we've got here complete cases once again, all this excellent stuff. And then this is what we started off class with. No, what do you mean by yes? Ahmed, 20 points, and Sarah for asking. Thank you so much. Great answer right there. Complete cases means that if you look at a row, it doesn't have any missing values. Like across a row in this data frame, nothing is missing. So if something is a complete case, and you know what we could do is we could do not complete cases to see things that are not complete cases. So this should get, see now we have the ones that are not complete cases. So if we scroll across, we should eventually see some missing data in here somewhere because it's not a complete case. And is it at the very end? Did we miss it? Where's the missing data at? Oh, it's because of this. I swear they changed this. Is it literally the last variable? Nope. Where's the missingness at? We could do the is.na. I'm going to lose my mind. There's supposed to be missingness. Oh, we got to find it. We got to find it. We got to find this missingness. Okay. How did I not see it? What happened? Lots of crazy noises this morning. What does the mean returning complete cases for rows? So what does it mean to return complete cases for rows? So that means the people who answered the survey answered every question. Yep, does that make sense? Does everyone understand what's going on right here? That I chose not the complete cases. So you see right here, this one right here, they answered GPA, but they have to have not, there it is. They have to at least not answered something else. So they did not answer this question. So you can see it looks like the missingness comes from fastest car speed and also GPA. So here's, these people they could be missing other things. They're just not complete. So we could see if they're missing another value. It's just kind of hard to scan here. What we could do is we could do a summary. This is the quickest way. Summary of sub right here. And we could see where the missing values are at. Where we see some missing. Summary should report the missingness. And there's the NAs. There's the fastest car speed had 1 NA. And we could do other ways. We're going to use watch this. We're going to figure out, we've already got the code for it, don't we? We're going to use the is.na. And so we'll store this as our custom function right here. And then we're going to run, so let's go to lapply, or let's use sapply. We were just seeing that sapply works. Let's apply it to our subset, and let's call our custom function. And there you go. There we go. Here's the 6 for GPA, and then there's the 1 for fastest car speed. And here's where it can get really crazy. Does everyone see this right here? How about we do not equal to 0? Does everyone see this? So now we found the ones that are not equal to 0. Now how about we go here, and what I first need to do, let me do this. Let me store this as an object. Let me call this results, because it's going to be easier if I store it as a small object. Results not equal to 0. There's the results not equal to 0. Let's go inside of results and go to the positions that are not equal to 0. There you go. Look at how much nicer this output looks. And look at how, looking through the code like individually. So sapply is smart apply. You can see behind me right here, I still think the sapply. And lapply is list apply. It applies to a list and returns a list. Data frames can be used as lists. Sapply is smart apply. It smartly looks at an object, evaluates what that object is, and then smartly does a return. So I don't have as much experience with sapply, but I know some people who are converts of the sapply way of doing things. Like a lot of people are like, yeah, I never use lapply. I always use sapply for everything because it's a smart one, and it says it down here like, I think it's up here actually. It's right where we're looking at it. No, here's sapply, lapply, and then sapply. So you can see a user-friendly wrapper of lapply by defaulting return a vector matrix if these things right here. So it'll try to smart return whatever the object is. So that's the way of going right there. And so if you look at this right here, think about if you were to put this into a report, this is what you'd want to return. Does everyone understand if you're writing a report, you would want to return something like this to say where your missingness is at? So we have here missingness in these following columns. And we could have also done this probably just for survey 11. So if we had just run this on survey 11, we should get the same results. Oh, wait. Survey 11, custom function, sapply. Oh, because it's doing it on the male females also. Oh, no, wait. Survey custom. What did the results return? Okay, that's good. That worked. Survey 11. Oh, I'm an idiot. There we go. Does everyone see we could have just done it on survey 11, so we could do it on our sub, we get the same results, and we do it on survey 11 because it's still only finding the missingness. So this little thing, this thing we've written out right here, and here's the beauty of this. You know what we can do with this? I'm teaching you things right now that are going to be super important. What does the output mean? These are where the NAs are at. So this reports to us where, like, how many NAs are in each column. Does that make sense? This reports to us now how many NAs are in each column. Does that make sense? Like the GPA column has 6 NAs, this column has 1 NA, and it only reports to us the NAs. Watch this. We go here to fun, and we say how many NAs, and we go to here, and we input X, and then inside of here we put this, and let's call this final. And then we go to return final, and then we go here, we call this X, and that's it. Now watch this, you ready? Let's go here to how many NAs. So we need something that has NAs. I think survey 9 does. So I'm loading survey 9, I type in how many NAs. I go to survey 9, and there's how many NAs. Does everyone see how the power of coding, you know what you could do? You could sort this. See, I'm already wanting to do more. So now we could go to these results, and we could sort the results by decreasing equals true. Oh, no. So we're sorting our results by decreasing equals true. And we run this again, and we run it again, and now it's sorted. How important is it to be able to know how to write a function to then, whenever you want to find out how many NAs are in a data frame, you can just ask it. You can just pull up another survey. You can say how many NAs, and then you can just put it inside of here with your custom function you've made, and there's nothing. It's a named integer vector, but there's nothing inside of it. So that's meaning named integer vector with nothing inside of it, because look, there's names, and it's an integer vector, but there's nothing inside of it. I'm trying to think if there's another data frame we have with NAs. I think the OPS, but I don't think I have OPS in here right now. But if there's another one with NAs, but this right here, this power of writing your own custom function, because now it runs all the code I want. I'm trying to think if we have any other data frames. I'm like, what other data frame would be really good? Like the alumni data frame, right? We just worked with the alumni data frame, so I need to go to your guys' assignment. Let me save this. File, save as. And I think I'm in the 320. I saved it. Yes. June 3rd. Everything we're doing here is super important because it's dealing with functions. Seeing the power of this, that if you have the alumni data frame, which I think we should see here, let me go to load, and it's the movie data frame. Sure, we'll see if the movie has any NAs. Oh, we can do it right here. How many NAs? Movie data frame. There's where the NAs are at. That's the columns, names, and how many NAs. And look at how little we have to run with our custom function. So easy, so nice, and that's why we do things like learning how to write functions, which we'll be doing very, very shortly in the class. But I put one in here if you want to take a look at the structure of how to write functions. All I did was put the code inside of it, and my function only takes how many arguments? We'll see in the chat, my function only takes how many arguments? How many arguments does my function take? You should know it pretty quickly. How many arguments does my function take? Oh, there's silence. How many arguments does my function take when someone tries to run my function? Oh no, are we online? How many arguments does it take? 100 points first person on these wacky Wednesdays. One, and you get the 100 points. Amazing job, Vidrana. I don't know, maybe like there's lag right now, but good job, everybody. Great job, great job. It takes one argument. Vidrana, we're giving you 100 also. Great job. That's on top of whatever you get because it's Wacky Wednesdays. So it only takes one argument right here. This is key, and I can't state this enough. You will need to know how to write things like this in this class right here. Caroline, 20 points. Great job. And so whatever someone puts for X right here, when I put survey 9, it literally goes and puts survey 9 right here. Does that make sense what's going on? That when someone puts in, when they put survey 9 right here and it runs my function, right here goes survey 9, and it runs the code and it returns this. Does that make sense what's going on with this function to a certain extent? That whatever is put in for this gets put into wherever X is at. Like this is X and this is what people are putting in. Like that's being put in right here. So that gets replaced right here with this. Whatever someone puts in. That's key. If you're noticing that, you're understanding how functions work. You know what you could do? Watch this. So let's put here decreasing. My brain's breaking. Decreasing equals true. And so, or we'll put this DC. Cool. And so that's that. And now, when someone runs this, it's set to true. And now it's set to false. Does everyone see whatever I put here for decision will actually augment what is controlled here? Just look at how it's highlighting that DEC is what is going to control here. And I also put a default for the function that if I don't put anything, it'll set it to true. So now this is true decreasing, but I can put in here false. You could put in true. And I can also call the function, oops, mistype true. I can also call it by DEC, and it'll actually show me it. This is a custom function now, but DEC, there we go. So understanding this right here and how I can build my own functions, you'll have an assignment on this very soon, coming up here very soon. So be prepared, be prepared. We did Missingness at the start of class. Please review the start of it, MD pattern, reasons for Missingness. This is a big thing right here. And this is where I started to think about Dr. Seaver again. When you have Missingness at random is what we usually want. Pretty much always. Missingness at complete random is good because then there's no pattern to the missingness. But if the missingness is not at random, that's an issue because that means your data, there's a huge thing. Like I could put a test question. Do you want things to be missing at random or not at random? What do you want? Missing at random or not at random? You'd want it to be missing what? You'd want it to be random or not random. What happened if you didn't add the second argument to your custom function? Would it stay as the default for DEC? Yeah, so going back to that real quick, and you would want at random. Yes, Madeline, 20 points right there, and Toss, 20 points for asking the question. You're saying if I don't have the argument right here, then I won't be able to control this. I'll need to remove this, and then I can't. So when I run this, you notice once it'll say like there's no argument DEC, but now there is no way when I'm running this function for me to change this. I don't have any I don't have a control for that. Does that make sense there, Toss? Like I can't, without that second argument, I can't control what this is. So I can put a value right here and I could just call this, I could call this Brian and I could set this for as Brian right here. So that's really bad argument names. But when I run this now, I'll run the function. The second argument is Brian. You shouldn't do that. But I could call true right here and it'll run. Or I could say Brian equals true. But you wouldn't want to call it Brian because you want to call it something that makes sense. You want to call it like DEC for descending. And then when you call that, then it makes more sense that you're talking about is it descending or not descending. Like you want to give it a logical name to it. Or when you call the custom function, if you built it with 2 arguments. Well, since it has a default, if it has no default, so if it has no default right here, now it won't run because it says it's missing the second argument. But by setting the second argument with a default, I don't have to call anything for the second argument. So if I don't put anything for the second argument, it'll decide for me that it's true. But if the second argument does not have a default, then it'll say, I don't know what the second argument is. So oftentimes we'll set defaults, especially for things like logicals. And if you think about the NA remove equals true or NA remove equals false, you don't have to write NA remove equals false or true because it'll set it for false unless you want to change it to true. So there's defaults, and that's how defaults work. Defaults make it so you don't have to give a value for it. It'll automatically do this unless you specify otherwise. Toss, amazing job. Those are some toss. You got 200 points. Amazing questions. It's Wacky Wednesdays. I like that you're like, wait, how does this work? And we'll be going very in depth on this. That's like, it's gonna be one of the hardest lectures. Writing functions, super hard. Hopping back to the slides right here. I knew something was odd. I was covering up part of that slide, and I was like, wait, I'm not on the slide screen. Like how the head function, yes, Jordan, 100 points. You're getting it. So the default for head is actually 6, and you can show that. We'll just show that off right here. Great answer. You understand exactly what's going on. That if we go here and type head, you'll notice that the default for head is this. Now this looks odd right here. So you're literally seeing how head takes object X, and then it says n equals 6L. 6L is actually the integer format of 6. Integer, I didn't type a capital L. Oh my gosh. So that's actually just 6, but it's in integer format, which means it takes up less memory. So 6L means integer format 6. That is what's going on right there, which 6 is probably numeric. So if you do class of 6, it might say numeric. And if you do class of 6L, we should get integer. Yeah. Integer takes up less memory. So R can be very concerned about like how much memory objects are storing. 6 will be stored in double decimal precision, Let's just put here more memory. And this right here is integer format, less memory. So it's just a smaller way for R to allocate what that is in its brain. Integer. So this is going deeper. Like, does anyone here code? I think someone said they code in C#. Like, memory allocation is a huge thing in coding. Like, when you get deep into coding, it's like, well, how much memory is this taking up? But it becomes less of an issue as computers become more powerful. But I guess still, if you're running like teraflops and stuff like that, then you might, like how many computations, it can become an issue again, because now we, just with the more power, we do more things. So why not still do things more efficiently? Very important in coding. So we have here right here, we want stuff to be missing at random. So very important. For example, we were trying to blah, 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 blah. Good there. Not all missing values should be imputed. So good stuff. 4 bytes versus 8 bytes. Oh, Connor, that's what it is. Yeah, so it's 4 bytes versus 8 bytes, and 8 bytes is double decimal precision, is it? So 8 byte allows for double decimal precision, and the integer is 4 bytes of memory. Because we were talking about this last semester, and then I looked into it more. So Connor was one of the reasons I started to look into the integer versus the numeric format. And then even I have to learn things as we go on and on. Connor, come back to me and, no, like, stay here. But come back in like 5 years and see where Brian's at. And then tell me things. Tell me even more. Because it's like, how exactly is this viewing it? So we have right here, detecting missing patterns. It's just so much to deal with. And we're to our final topic for today. Our final topic for today is the first time we'll be using the A rules package. Please take a note. This is the first time we are using the A rules package. And Connor, something happened. Are you still here, Connor? Something happened this semester with the A rules package. This happened right here. And I don't know what that means. I don't know what this is. It seems to be somehow associated to the support. But I'll have to look up what coverage is. Let's hop over here to the screen. So Connor, you might have to tell me what coverage is, because this appeared in the A rules output. So the A rules output now has this new variable, coverage. I don't remember it either. It's new. They updated the A rules package. And so the output was like wider than I expected. I was like, what's going on here? And then I looked and I was like, there's another variable. So unfortunately at this point, I can't tell you what coverage is because I saw it this morning. And as Connor, I'm so glad I asked Connor to come in and support me by saying, I don't remember that. But in truth, this is something I didn't know about till this morning. But this is the first time we're using the A rules package. And we're going to have a very packed 6 minutes to end class. So pay strong attention right here. We have here a data frame where we have 3 variables we're investigating. We are investigating quantity 3, quantity 7, and quantity 6. And we want to know the way in which these things are missing together. Does anyone see numbers over here in the counts that kind of jump out to you? 20 points. Who sees numbers in the counts that jump out to you right away? What would be the correct way to interpret line 6? Ah. Maybe this is a homework question. Given quantity 6 is missing, how does that impact quantity 2 missing? So read it this way. Given quantity 6 is missing, how does that impact quantity 2 missing? 20 points, Madeline, and everyone else, Andrew and Toss and Ahmed. So given, and Sarah, sorry, I missed you, Sarah, there. So given quantity 6 is missing, how does that impact quantity 2 missing? Given quantity 6 is missing, how does that impact quantity 2 missing? So then, and you guys notice the 474, so let's do some of these. Let's do these ones right here. Line 7. Given quantity 7 is missing, how does that impact quantity 6 missing? So Andrew, you're close. The support tells us what percent of the time both things are missing. Now notice how the support for these are the same, because it's like what the support means for this rule, and this is the support for a rule. Quan 6 and Quan 7 are missing. Yes. Bingo. Jordan, amazing job, Jordan. Also called cover of the left-hand side support is the support. It's the support of the antecedent. Is that correct? Wait, we get the antecedent, and why can't I remember the correct names for them? The consequent. The consequent's the other name. Yeah, it's antecedent and consequent. Oh my gosh, Connor, thank you so much for Googling things in the background. Okay, that makes perfect sense. And then it also makes sense. So this is, and as it says, it's the support of the left-hand side, which that'll help when we're teaching things later on. So what would this be? Wow, we got to add this to the notes because they literally just added this. I don't know how recently. They've added it in the last few months because we were using this 2-3 months ago and it didn't have it. And I've updated my A rules package. Maybe I didn't update it before. What does this coverage tell us? Quan 7 is missing 0.6311% of the time. And look what they put that right next to, Connor. They put it right next to what? The lift. Because that is what will get lifted. Wow, that's awesome. I should have guessed it. They put it right next to the lift because this is the original, let me highlight it. This is the original probability that Q7 is missing, quantity 7 is missing. And Adam, you're right. My gosh, you guys are awesome. If you've been reading the notes, what's going on here? I got so many good answers. Adam, 20 points right there. So let me go through each one of these and tell you what each means as we talk through it. I'm going to read through one rule right here, and we'll do a few more, but this is a jam-packed. We'll start next class with this too, but I want you to hear it today before we go. Given Quan 7 is missing, how does that impact Quan 6 missing? That's how that is read. Support. Quan 7 and Quan 6 are missing 63.11% of the time from the data set together. Like, both of them are missing, as in, like, how often are both missing from the data set together? 63.11% of the time, they're both missing from the data set. So that's how often they are both missing. Confidence. Given Quan 7 is missing, given Quan 7 is missing, the probability Quan 6 is missing is 100%. Given Quan 7 is missing, the probability Quan 6 is missing is 100%. Coverage. Thank you, Connor. Quan 7 is missing 63.11% of the time from the dataset. That only talks about Quan 7. So, and it's the left-hand side, is it? Wait, is it the left-hand side? So if it's the left-hand side, given Quan 6, how does it Quan 6? I wish it wasn't the left-hand side. Why don't we get the right-hand side? That's a bummer. I actually said one wrong thing then. So if it's the left-hand side, then we can't multiply this by the lift to get the support, right? I mean, not the support, the confidence. So we can't multiply it by it because we can't go by this right here to get it. Yeah, we can't because this is like 1.5%. I want the right-hand side. Why wouldn't it just give us the right-hand side coverage? Or, yeah, I don't like that. Okay, I'm done with coverage. Don't like it anymore. So This right here is the left-hand side support. So it is the probability that the left-hand side is missing. But to get the probability that the right-hand side is missing, here's the last little bit, so we got 1 more minute. Lift is very important. Lift means the probability that Quan 6 is missing has been raised by a factor of 1.58. The probability of Quan 6 missing has been raised. So let's see right here. We can get the original probability of Quan 6 missing. So write this down. This is our last note for the day, and I'm going to solve it. So support for Quan 6 is equal to, we're going to call delifting. We're going to take the confidence and divide by the lift. Please write this down. This is our last minute. This equation is very important because you can see other things. That lift times support equals confidence. That'd be support of Quan 6, though. That's support of Quan 6. Could you do 1 minus left to get the right? No, you can't. Good 20 points there. You can't. And I'm blocking this note. So that is lift times support of Quan 6. Lift times support of Quan 6. We will be covering this tomorrow. I know I went through this quickly at the end, and it's end of class time. But interestingly enough, and you'll be like, wait a minute, what's going on? Because watch this. 1 divided by 1.584338 is the 61.115. And you say, wait a minute, isn't that the same thing over here? But watch this. Let's put in the confidence for this rule right here, the rule in the middle of it. Let's put in the confidence for this rule. This will be covered tomorrow. I don't expect everyone to get this right now. And divide that by the lift. And now we get this. This is the support. 200-point question. Brian just calculated the support for what? 200-point question. Watch again. Last 200-point question. Brian is going to do it here. It's Wacky Wednesdays. I'm going to calculate it again. Brian is calculating the support for what? Brian is calculating the support for... You got it. Madeline, you're right. Madeline was first. And Jordan, I'm throwing Jordan an extra 100 right there. But you know what's interesting? Connor, we could figure out via the coverage. You know how, like, I just figured out the support for Quan 3? But look at this. You see how here's the coverage? We can use the coverage here to say this is the support for Quan 3. And then we would know the support for Quan 3 right here. So we know the percent of time Quan 3 is missing because we have the support for Quan 3 right here. So we could get the original support for Quan 3 right here. Does that make sense? Maybe you just said that. But you could use it because I was like, yeah, what I calculated by doing this calculation here. Does that make sense, Connor? So we could use other supports to do it. But yeah, it's craziness. Man, people are loving these points right here. Connor, how are you doing? My neighbors aren't super mad at me. Get complaints. I hope the new apartment complex I move into is pretty happy. I hope they're not like... It looks to be... Hopefully... Just like... Could it not be Quan 2? Which one? Do the mathematics. Which mathematics are you talking about? Yeah, I've been pretty good. Still going to Texas, yep. Like July 3rd or 4th, around there. I've got to figure out how to move my massive green screen down there. That's the thing I'm most concerned about. This, might hear me hitting it right there, but this is the wall of the green screen. I'm touching the 5. I shouldn't probably touch my green screen. It's a good way to get like grease and gunk on it. But the green screen it's literally just like as long as I could reach. It's longer than I can reach my arms. It's just barely outside the span of my arms. So it's probably like 7 foot longs. Vidron, you're cracking me up right there. Oh, I love coding. It's so much fun. It's so much fun. Is that a quote from someone? Because maybe I said that today. I don't know. What have you been up to, Connor? How's your summer been? Call the coding, please. And Andrew and Vidrana, you get an extra 20 points right there. You can tack it on. You're hanging out. If you have questions about the homework or anything, I don't know if 320 is back in the room right now. This is office hours. I'll keep hanging out till we get some questions. I think we're almost done with these notes. And the next assignment is posted. Oh, I'll need to send out a reminder. 453 is the class I am in right now. In right now, literally? Or like, and what is 453? Is that IMNT? Which is 453? We'll talk about the output of rules a little bit more tomorrow. Cool stuff, but more of a topic for grad school. BAUD capstone. Oh, cool. Yes. Is that... I don't know if I don't think I enrolled in that one. I should do that. Like even my brother's using Amazon Web Services. That was my neighbors would say to my landlord. They're like, he's talking about coding. We have no idea what he's doing. What's going on? I'm just like, I'm hoping the new apartment complex we move into, like I probably need to like go to my neighbors and be like, hi, you're going to hear me teaching classes probably. And please tell me, and I will work to make the room as soundproof as possible. Like, I'll be like, am I over your bedroom? Like, we've got 2 bedrooms, so I probably need to figure out which bedroom is going to be the least. But, you know, people stream online, and then I've heard people saying, like, my neighbors are mad at me and stuff like that. But I'm just shocked that there was a knock at, like, what time did class start? I didn't even think what time class started. 9:45, 9:50? I'm like, wait a minute, wouldn't they be knocking at, like, 8 a.m. when I was like, what's up? What's up, 320? Whenever you get the chance to explain how to find offending levels. What is it's the offending levels. Which one is this again? Which, Madeline, which thing is this? Oh, A and B for 474. Is this the latest assignment? You guys got it. Let's do it. And I'll send out a reminder today that there's an assignment due tomorrow night. Is this the latest assignment? It sounds like it. Let's do it. Validations and dates. Okay, we are downloading assignment. We are getting it loaded up. And let's see right here. I sound like a robot. Are we on? I think we're on the little screen right now. No, we're on the main screen. I thought we were on the little screen because of that. Okay. Second homework, you got it. Which question? We got 6A and 6C. So let's go ahead and do 6A and 6C here. Let me make the screen more normal. Here's normal screen. And 6A and 6C. 6A and 6C. Okay. Provide a frequency table using unlist and lapply. Whoa! Yes, I like it. Okay. Which data frame are we using? Too much craziness. Okay, cool. That all loaded up. Provide a frequency table using this right here of the number of missing values for each column. Wait a minute. Wait. Guess what we got? And it was in the notes today. Let's go back here to our notes right here. We want the number of missing values. So we're going to take, we'll use the simple version of it. We're going to take this function right here. And let's go back in. Let's drop in our function. And then we're just going to change the data frame name to by2. And we go right here. And I think we've done it. We could just put out the output. And there it is right there. Boom. Got it. So here is, it's wrapping around the screen a bit odd just because it's being odd. There we go. Now it looks more normal. So this has it right here. This is a code from today's class. This is the lapply using the custom function we made today. So the custom function is we're taking the sum of the is and a's. You can also use sapply. So we found a much quicker way of doing this today. I mean, I've seen it before. And I think Connor, maybe we talked about it too. But sapply could also do it. And then we could also sort this. Does it say to sort it? So what fraction of the values are missing? So if it wants fraction of the values, if it wants fraction, we can go here and do divide by n row by 2. And it wants 0 to 1. So there we goes that. I hate the way that looks. And let's go here and go round. Let's go to round and go to 4 digits. Still, one of these is just so small, isn't it? Is this one causing our problems? Connor, you're so good at this. I'm wondering, how do you take off scientific notation? I could multiply this by 100, and then I would get percentage. And now it's as a percentage. Whoa! Rank category is missing 98% of the time. So it doesn't want it to be reported this way. I mean, please tell me if you get points off and you do something like this, but I think this is fine. I would prefer if I'm getting a report from my business people like this. And why are we getting... Let's store this as an object. Let's call it object O for object. No, O's looks like zeros. Let's just call it data frame vector. It's a vector. Call it what it is. And then let's go to round of my vector 4. There we go. And maybe, you know what? So maybe we didn't need to do that. There we go. Fixed. Oh my gosh, Connor, you are so good at this. So the thing, Connor, man, I should have known it was options. It's always options. So Connor has in here where the scientific notation will begin. I shouldn't do this. Shouldn't do this. Huh? It'll begin after that? Wait a minute. Okay, wait, how's this work, Connor? I thought it'd be getting scientific notation. Okay. Maybe it wouldn't accept that. Oh, now it did. Maybe I didn't run it. No. Let me try this. Let's try 20. Yep. I think it won't accept such a slow number. Yeah, we can do the next tier. And then we got 6C. So please don't enter in the randomness Brian enters in. He's just trying out new things. I'm going to set it equal to 10 for now. And now it'll begin scientific notation. I don't think we need the minus the times 1. I just thought maybe it needed to do a calculation. So this will begin scientific notation. Eventually. What? Oh, it looks like... Is the default 14? That's so odd. I am very confused here. How does the SciPen work? Because it doesn't seem to use the exact number I put in. It's related to it. I know, right? Like, it's related to it. Like, I'm adjusting it, but it's not directly how many decimals there is. I gotta know. Options is going to have so many options. Like, that's going to be find in topics. SciPen. A penalty to be applied when deciding to print numeric values in fields. Positives, numbers. It's pretty complicated. I mean, why can't we just... Yeah, I know, right? That's pretty complicated. I'm like, it controls when we do it, but I don't know. We'll look at 6C right here. What's 6C say? 6C says the following code performs a more rigorous analysis, missing value patterns. Okay, let's take a look. Cool. Provide a comprehensive interpretation of Rule 2. What does this mean right here? Who can interpret what this rule means right here? Very important. We're at the very end of this assignment, which is good. It's due tomorrow night. Was that how? I like that, Connor. What does this rule mean right here? Yeah, tell me the other way too. You're welcome, Kelsey. What does this rule mean right here? You could turn it into I wouldn't do it for it, but you could. I wouldn't, at this point I wouldn't do it. The question doesn't ask for it, but you could turn it into a fraction. But it wants kind of like a 0 through 1 number. So I wouldn't use fractions, but it's a cool function. Like, if you do it, like, given high, the given high is missing. Given we don't have a value for high, how does that impact the probability of low being missing? Does that make sense? Given we don't have a value for high, how does that impact the probability of low missing? Does that make sense? Given that high is missing, how does that impact low being missing? So given high is missing, how does that impact low being missing? So make sure to reference the overall fraction of missing. Provide a comprehensive interpretation of Rule 2, including reference to some of the numbers in that row. Make sure to reference the overall fraction of lows that are missing. there's a very interesting implication this rule has, which ties back into the last. Okay, we'll points explain. So, okay. So let's go ahead and look at this rule. Oh my gosh, it's so much output now. What have we done? So I'm going to have to make it full screen right here to look at the rule. And so we should get inspect the rules. Where's inspect rules? Why am I losing my mind? Oh, here's inspect rules. I don't know. I could have just written it. So high, given high is missing, how does that impact low? So here it is right here. Here's the rule. Okay, we need a full interpretation of this rule. You ready? So given high is missing, how does that impact low missing? What does this mean? What does this mean right here? What does that mean? What does this mean? High and low. Just go in order and always try to do them in order and be like, okay, support means support for the rule specifically. This is support for a rule, not an item in the rule. So this means high and low. You guys got to tell me. You got to tell me in the chat. There's close, Madeline, close. High and low are missing from the data set 3.08% of the time. It's the missingness of the whole rule. So high and low are missing from the data set 3.08% of the time, or 3.086, or 3.0865. Could round those. 2 decimals is fine on percentages. So yep. So it's the percent of time, the probability that high and low, and then we should say maybe are both missing. Yeah, we'll do it. You got it. We will do number 4, and then I think people want number 7. So 7 and then 4. You got it. Both quantities are missing, and then make sure to say something like together. So it's not like, because imagine this, you could have like data missing here and data missing here. And so if you had a data frame that looked like, here, I'll ask, ooh, this is a really good question. Let's do this. You ready? Okay. This is really good practice if you do this. And I think I might be able to even run rules on this. I didn't put a comma there. That's gonna be a problem. Wait. Sure, wait. It's gonna abbreviate. It didn't make sense. And okay. Yeah. This is go to Bry. I like it that it lines up. Okay, so here's my data frame. And I want you to look at this data frame right here. So we'll run it again. When you look at this data frame right here, what is the support for the rule age GPA? If you saw age and then arrow GPA, what is the support for that rule? What is the support for this rule? What is the support for the rule age GPA? What is the support for the rule? And it's how often both of them are missing together. So this, Connor, your mind might be on regular market basket analysis. It'll be, you got it, yep. Because what is considered the basket right now is the missingness. So we're analyzing how often are things missing. See, I can hear my neighbor now talking loudly. I'm not going to bang on the wall. So we're going to say that the support means how often they're both missing together. But what is the support for this rule right here? What is the support for this rule right here? What is the support for this rule? What would be the support for this rule? The support for this rule would be what? Who knows what the support for age, how often? Yep. Because they're missing together 0% of the time in the data set. So the support for this rule would be 0 because they're missing together. There's no point at which age is missing and Bry is missing. But previously we put GPA here, and these examples right here hopefully show you that this would be calculated that 20% of the time age and GPA are both missing in the data set. 0% of the time age and Brian are missing in the data set together. And this is like together missing. What is the next one is, let's look at the next output. The next output is confidence. What is the confidence for age GPA right here? Given age is missing, then would be how confident GPA is missing. Given age is missing, would be how confident GPA is missing. Given age is missing, how confident would we be that GPA is missing? Given age is missing, how confident would we be that GPA is missing? What would be the confidence of this? Awesome. So good to see you, Connor. Definitely. So glad. Email me anytime, man. I'm excited. So what is the confidence right here? Given high is missing, yes, and Vedrani, you're right there. And it's 1, and then this one also up here is 1. Let me make sure. Are we interpreting? Yes. Given high is missing, low will be missing 100% of the time. And we might not even say we expect. We might just say is missing 100% of the time because it's not a model that's talking about future data. It's talking about the data we've collected. In this data, when high is missing, like given high is missing in our data set, low is missing all the time. Low is always missing. And that's why I did this example here, because given age is missing, GPA is always missing. The confidence here would also be 1. Does that make sense right here? So this is a confidence of 1 because given age is missing, GPA is always missing. This would be a confidence of 0 because given age is missing, then Brian is never missing. So the percent of time Brian is missing, like given age is missing, Brian is missing 0% of the time. Because you'd only look at this right here. You'd say given age is missing. So you'd go across, it won't let me highlight across a row. Or maybe it will. There we go. Given age is missing, specifically this one right here, Brian is never missing. So this would have a confidence of 0. Does that make sense? Given age is missing, and we could even put in more NAs for Brian, but if we don't put in NA here, like we could make a confidence. I gotta talk correctly. This right here, we could put in another NA here. And now when we look at this data set here, which will run it, copy this. So now the rule, age for Brian, this rule right here would say, given age is missing, and so what would be the confidence for this rule? What would be the confidence for this rule? What would be the confidence for this rule? Who knows the confidence for this rule? What percent of the time is Brian missing, given age is missing? So given age is missing, Brian is missing this percent of the time. So you only need to look at the times age is missing. Given age is missing, Brian is missing. Yep, if you draw, I think, or maybe that was the old answer, but it is the answer. That's the old answer. I just looked up and saw the old answer, which is this is going to have a confidence of 50%. Does it make sense when I show these examples, I hope? That given age is missing, Brian is now missing 50% of the time. That's the confidence. How confident you are that the right-hand side will be missing given the left-hand side is missing. What is the support for the rule right now? Who can tell me in the chat the support for this rule? So the support, remember your notes on it, the support for the rule is the percent of time both things in the rules are missing. So what is the support for age Brian for this new data set? The support for this rule, age Brian, in this new data set is what? The support for the rule is what? What is the support for the rule? I'll see. 20-point bonus, office hours points. Need my coffee now. Yes, Madeline, you're right. Yep, it's still 20%. Because you would look at the full data set across here. What is the only rule that has a support of 0 right now? There's 2 rules, actually. Give me a rule that has a support of 0 right now. So 20 and Madeline, 20 points right there, and Caroline, 20 points. Great job. Give me a rule that has a support of 0. Write a rule in the chat right now that has a support of 0. If you're practicing this, you are learning this really well. You'll be like, okay, can I write a rule for this that has a support of 0? See, this is how I can write test questions right here. I could show you this small data set, and I could give you a list of things. And I could say, pick a rule that has a support of 0. Very drawn at 20 points right there. Pick a rule that has a support of 0. GPA, yep. GPA Brian. So the 2 rules we could write, I'll put them here in the chat, or I'll put them on the bottom. Like we could write GPA, how does that impact Brian missing? Or we could simply switch it. It's going to, sure. We could go how does Brian imply GPA missing? So Brian GPA or GPA Brian. And then, but age GPA has a support of 20% due to this. Because 20% of the time, age and GPA are both missing the data frame. So age GPA, yeah, I know, I just typed, it was the 3-letter word I thought of. So age GPA has a support of 20%. where if you look at GPA Brian or Brian GPA, there's no point at when Brian and GPA are both missing. Remember the support for a rule, and I keep saying for a rule because what is the support of age right now? Can anyone tell me the support of age in this data set? Which is not, I think I can do, I might try to run it on this. I'm going to try to run the a priori learning method on this. What is the support of age in this data set right now? What is the support of just age? 100-point bonus question. What is the support of just age? So you'll hear me say the support of a rule or the support of an item. What is the support of age? So think the support of a rule is the percent of time both of them are missing the data set. So what would the support of age be then? If it's just one thing. If we're just looking at the support of age, what would it be? Madeline, you were in that 100 points. That's what the support of an item is. So that's, well, I think I can run this. Let's see. You know what I could call it? I don't want to call it V. It has to be transaction data, doesn't it? Oh, but we can take it. Okay, by 2, and then we're just taking those columns, and we're just calling it data. Okay, so sure. Let's go here. Let's go data, df, cool. We did it. I love it. I love how code can just get you what you want if you know the little thing to change. All I did was circumvent the code, and I'm like, nope, I don't want by 2 to be the data frame we're going to analyze. I want my data frame. So everything right here, you know what you could do? Watch this. Which I think we're just looking for the inspect rules, which is all we want. So right here, yeah, all we wanted was the inspect rules. So I'm going to take, and I'm going to delete out all this. I'm going to change this to require. And then I'm going to go here. That's good. This is what you should, this is what we want you to learn in the class. So what I'm about to show you is the whole power of this class. I'm going to go here. I'm going to go fun for function. And the goal is to get this. No, we don't want that. We want the inspect rules. And inspect rules should make the output by itself. And we go here, drop this inside of here. I hate that it's wrapping around the screen. Not much I can do about that. And this will take, we have to take this right here. Or it just takes data. That'll be fine. And let's call this make rules. Okay. So what I should be able to do now is I should be able to use my function make rules, and I can put in my data frame, and it makes the rules. This, if you can't see, this is the power of coding. I keep saying that today. Like, my neighbors are banging on the wall. They don't want me to show you the power of coding. They know I'm showing you some cool stuff right here. But look at this. Make rules for a data frame. I could literally go here to make rules. And you remember how we were looking at survey 11 earlier? There's, wait, oh no, I know why it's doing this. Because data is this, and data is saved as df. So I think, let me remove out this. Let me go to the make rules. Where's my make rules? Require your rules. Okay, we're good on that. Let me see. Oh, I did make rules df, right? Let me do make rules this. Survey 11 not found. Well, that's obvious because I don't have array class loaded up. Rules not found. Inspect rules. Oh, I didn't make the rules. I deleted it. I need to make the rules. I didn't do the a priori. I deleted my a priori. No. Did I seriously delete the a priori learning method? Where did I delete the a priori? Is significant. Require rules. I'm losing my mind, everybody. Losing my mind. There it is right here. Wow, I deleted way too much stuff. Yeah, I didn't create the rules. Item frequency transactions. We don't need item frequency. There we go. Last try. Last try. This becomes make rules. Sure. This becomes this. This takes data. This becomes require. Because we're going to require that to be loaded. We run that. And then we go here. We go to make rules. Survey. And now we need to return this. Run this here. Oh, is it doesn't will not do it? So we could take and we could do this. We could super save this. Sure, this won't explode now. Because it's doing it in function world. Cool. Okay, then it got the rules. What? Okay. Well. That's a bummer. I'm so bummed. And I deleted all my output down here. If you remember the data frame I made right here, please take a look at this data frame right here and the way it looks. Because this output right here is so very important. Understanding how often things were missing, and I think we updated it. Oh, is that a... There we go. There's the one for how often. This is the support right here. Here's the confidence. And we can see all the rules and all the different things we were talking about with things with a confidence of like 5%. And we see right here, Brian, age Brian, all this right here. Everything looking pretty good. So continuing on, age Brian, got it all. I think it's something, looks to be a little support. Do we change it? GPA. Oh, it didn't report GPA, Brian, did it? Brian, age. It didn't. Why didn't it run all the rules? Oh, because I think it's doing a limited report on the rules. That's why. Because we should get 1, 2, 3, 4. My brain is just breaking, guys. GPA. Brian. I don't know why it's not reporting all the rules. I think it's the way it's reporting. Oh, okay. I'm going to stop going off on tangents. Let's get serious here. Are there any questions about how to interpret what's going on right here? Are they statistically significant? That's just p-values. We talked a little bit about p-values. It just means something has a p-value below 0.05, and that'll report trues and falses. What does it mean for a rule to be statistically significant? That what we're seeing is unlikely by random chance. It just means that we think there's something actually going on here. And then we'll hop to question. I think the next one was question 7. What was it? Question 7A and 7C. 7A and 7C. I want to figure out what's going on with that function, but it's driving me nuts. We'll do 7A and 7C, and then we'll do question 4. If you're in 320, hop in and say, hey. So let's hear and do 7A and 7C. In business analytics, we very often transform data that we collect in order to make algorithms work. So imagine that a model predicts the log 10 of the closing prices of stocks. The model outputs these values right here. So, oh, they're already there. Cool. So here's the values. And the numbers output, print to the screen the untransformed values. What can we do this? Hey, yo, what up, Brennan right there? What can we do to these values to untransform them? They've been log 10'd. What can we do to these values to untransform them? There's a super quick way. When you see it, you'll be like, oh, no way. These are the predicteds. So what can we do to these values to unlog 10 them? Remember, they've been log 10'd. And I feel so good about this assignment because we've covered a lot of this. Like, we really covered this well today. Like, we did a lot of this today. I look over the assignments and I try to make sure we mention the things in class and we specifically do examples. So don't worry if you're asking this. I'm sure people are like, I don't know how to do it. And if you don't know how to do it, just be like, I got no idea, Brian. Don't worry. It's in today's video and I will do it and I'll show it. But I want to see what people say. How can we unlog 10 these numbers? How can we do it? They've been log 10'd. Now we want to unlog 10 them. What could we do? There's silence. Even if someone doesn't know, be like, I have no clue. Who knows? Close. Madeline, you're so close. That's what we would do if they've just been logged with the base log. So you're super close. I want you to think through it. You're so close. They've been log 10'd. They haven't been natural logged. They've been log 10'd. They have not been natural logged. So think what you have right there. They've been log 10'd. They haven't been natural logged. You would do that if they were natural logged. The reverse of the natural log is to raise them to E. The reverse of the log 10. Not multiply by 10. So close, Brennan. Brennan, I'm throwing you 100 points for just trying that right there. I like you're not even in forcing 4. I like that try right there. You're so close. Look at what Madeline has and augment it. Madeline, you get 100 too. We're going crazy. It's Wacky Wednesdays. You guys are here for office hours. So I'm going to slow down the points tomorrow. It's crazy points. What do we have? You're so close. Your answers almost just need to be put together. So close. So close. So close, 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 close. You're so close. I like it. You're so close. Let's try something. Let's try log 10 of 1. Okay. If I want to undo that, what would I do? So I'm taking the log 10 of 100, and it's 2. So think about this. If I have 2, how could I turn that back into 100? Close. People are getting super close. Like, don't put together the E. The E won't be used because it's natural log. Put together the theory. Put together Madeline's theory with the other one. So Madeline, you were the closest, I'd say. Madeline, you're the closest. Like, yours required just such a little augment. It requires, like, Brennan's kind of suggestion. We're super close. We'll have it done in, like, 1 minute. Don't worry. Like, I could start the clock. Like, wait. Set a timer for 50 seconds. Vidrana's even closer. Vidrana's... Oh, wait. No, Vidrana's answering this one. Vidrana got it. 100 points for Vidrana, right? Vidrana. So Vidrana's right. You are right. That undid it. So how would we undo that vector? We've got 30 seconds left. How do we undo the vector? Think about what we just did. We just turned that back into 100. How would we undo the vector that's been log 10'd? You can type it in the chat. Don't worry. If I'm asking things like this, I want you to type in the chat. We've only got 17 seconds left. The time is counting down. How do we undo the vector? It's 5 seconds. Oh no. You guys got to help out. How do we undo the vector? I did repeat. That's bad. You're so close. We've almost done it. Someone's late. What do you do? Vidrana unlog 10 2. How would you unlog 10 the predicted's vector? So think Vidrana unlog 10. Well, no. So you're close. So stay with what Vidrana's done. She's unlog 10 2. We want to unlog 10 a vector. So Vidrana unlog 10 2, and we want to unlog 10 a vector. Well, remember, it's still log 10. It's still log 10. But you're now doing it to you're unlog 10ing a vector. Does that make sense? So wait, remember, you unlog 10 2. So look where the 2 goes. Now we want to unlog 10 the predicted vector. So think about, you made it work for 2, and now you want to make it work for the predicted vector. So think about what's going to change in your answer if you want to unlog 10 a vector of numbers. So listen again, I think you'll hear it. You have unlogged 10 2. Look where the 2 is in your answer. Now you want to unlog 10 the predicted vector. So think about what will change in your answer of 10 to 2. Wait, don't use your original answer of 10 raised to 2, and then you've got it basically. You're right there. Excellent work. You're right there. But don't do log 10 of it. Don't do log 10 raised to it. Remember, to unlog 10, you do 10 raised to the number. And now it's just going to be, I want to see it in the chat. I want to see it. Well, wait. Remember Vidrana's answer was this right here. I'll put it in the chat. So that's how we unlog 10 2. So now how do we unlog 10 a vector? So remember, that's where 2 was at. So now how do we unlog 10 this vector How do we unlog 10 that vector right there? How do we unlog 10 that vector? Because that's how we unlog 10 too. How do we unlog 10 the vector? I want people to have these light bulb moments. I want them to be like, boom, okay, I see it. That's how we unlog 10 a vector. That's it. Everyone had the light bulb go off, right? Look at we got 2 answers right there. Yes. Perfect job. Extra 100 points. I don't care. You know what it is. It's Wacky Wednesdays. It's crazy points today. Putting the max points at 300, so it's a Wacky Wednesday. Wacky Wednesdays, I can do whatever I want. Points just go nuts. So, does that make sense? We've now unlogged 10 to the vector. We've now unlogged 10 to the vector. And we've got here, imagine that a model made predictions on a transformative checking balance. In the raw data, the minimum of checking balance was this. The model predicts the log 10 balance after this has been added. Okay, so let's do this. Let's go here and put here values. And the values are going to be something like, the lowest value was negative 512. And then negative 5. And then 8. Okay, so we're going to go values. And we're going to overwrite the values with values plus, and you don't need to do this in your assignment. I know, right? I was like, oh no, we're so close. Like we'd get closer and we'd walk away from it and I'd be like, no, let's go back. And so now we're going to go here and we're going to log 10 these. Okay. I want you to look at these steps right here that we got to get the new values. Does everyone see the steps we did to get these new values? So when we undo these steps, we have to go back this way. So does everyone see the first thing we will do is we will do what to the values first? What if we're going to go back up this thing, so we will first have to remove the what on these values. We will first have to remove the what on these values. We will first have to remove the what on these values to undo these steps, because it said they added on 513 and then they logged 10 to the values. So going back up the steps, we're first going to have to undo what if we go backwards to undo what they did? What will we do first going backwards to undo the work they did? Because this is a theoretical, like, let's make some values. Let's add 513 to them. Let's log 10 those values, and then let's see what the values are. Going backwards, the first thing we're going to do is what? We are going to what? What shall we do? Undo the log 10. Boom, we already know how to do that. Nice job. Look, you're already, Brennan, you're doing 474 work. Amazing job. You're getting the cap 300 points today. I love it that you're here, you know, practicing along. We're just going to undo these values right here. We're going to unlog 10 them. And then what do we do next? What do we do next to these values right here after unlog 10ing them? Go to the next thing we got to undo. You got it? Look, there we go. There's the original values. These are the original values right here because we just worked back up the steps. Now, if you're doing this work along with me, don't put this work in here. Don't put, I think we can do new. Is it? Oh, no. Oh, gosh, what did I do? Oh, no. Oh, I only opened window 3. Okay, good. I did a quick command. I think it's Control-Shift-C. Is it? Yeah, that's block comment right there. So there's I learned so many things that students teach me. This is the block comment feature. It's Control-Shift-C, and it does a block comment. And now it will not let me adjust the window frame because I think it's treating that as window 1. That is so weird. Oof, I don't like that. Okay, I'm going to do something bad here. Oh, good. That did it. Control-Shift-2. It's controlling how I look at my windows. And I've seen that before in the background. So does everyone understand this right here? I hope. So some algorithms, clustering algorithms, require something to be standardized. Oh, man, we got this. So standardize it and show it as a mean. Okay. If we standardize things and they have a mean of 0 and a standard deviation of 1, they're what's? If we standardize things so that they have a mean of 0 and a standard deviation of 1, they're what's? Things that have a mean of 0 and a standard deviation of 1 have been turned into what's? What have they been turned into? How can we turn things into so it has a mean of 0 and a standard deviation of 1? The answer's on the screen. How can we turn things into having a mean of 0 and a standard deviation of 1? This is a big question. It's very, very important to know this, that if something has a mean of 0 and a standard deviation of 1, it's a what? Here's part of it. It's something this. It's this something, actually. It's blank this. So if something has a mean of 0, because we've took the difference and divided by the standard deviation, and the difference from the mean would be 0. So if something has a mean of 0 and a standard deviation of 1, it's a what? There might be 2 people watching right now. I'm gonna see how many people are watching. It's like 1 person. 18? What? Everyone's like, where's the answers, Brian? It says unable to connect to chat. That's from a long time ago. Hopefully everything's fine. Hopefully. Sometimes I worry, am I still streaming? So something with a mean of 0 and a standard deviation of what has been turned into what? Mean of 0, a standard deviation of 1. Thank you, Brandon. And Brandon, if you have questions. It's a z-score. Yep. It's a z-score. So these are all z-scores down here because this is on the standard normal curve. Great job right there. Awesome stuff. I was worried. I was like, maybe the one chat says like disconnected. And I was like, uh-oh. So a mean of 0 and a standard deviation of 1. These are all z-scores. So how can we turn these into a z-score really quickly? How could we turn this? Does anyone know the code to turn these into z-scores? I'll give you a hint, and it was shown in class today. Who knows? For 20 points, who knows? That hit the light. Juggle balloons. Ha! I don't think I can juggle balloons right here. Who knows the code? Balloons are too hard to juggle. Could juggle them if they weren't balloons. They don't fall correctly. I've had those balloons there for quite a while. Those balloons have stayed inflated for like 3 months. Where's mine? I'll be right back. You guys got it. It is scale. It's hard to juggle in a chair. I don't know if that can be seen. I'm going to hit the microphone. It's so hard because my elbows are like hitting the back of the chair. I just hit myself in the face with this dirty tennis ball. Oh, it's too hard to juggle in a chair. Hit the chair against the wall. There we go. Okay, there we go. Not used to juggling. Harder to juggle in a chair than I thought. Okay. Fun times. Wacky Wednesdays. Wacky Wednesdays. I should have started. Maybe I'll start next Wacky Wednesday with that. I've got juggling clubs and stuff too, but Wacky Wednesdays. It is scale. Let's go here. Scaled. Boom. There we go. And then we could do this. Now, people have said this to me. People have said, wait a minute. This right here is not 0. It's -4. Who knows why this is basically 0? Who knows why this is basically 0 right here? Like, I've had people say to me, like, on these questions, because we use similar ones, but they'll be like, that's not 0. And I say to them, well, I mean, I'm like, that's my answer. I'm like, well, you know, what's going on with that? Why is that when I say like, well, yes, but no? When they say it's not 0. I'm like, okay, you're right. but it's basically 0. Well, so what it is, so this is not like multiplied together. This is great questions right there, Brandon, too. This is scientific notation. So you can actually put this into R right here, and we can see, and I think we could do options. We're going to do the thing we learned earlier. SciPen equals, and that's what this is. So it's a very, very tiny number. SciPen, and I think Connor's going to email me some stuff, controls when scientific notation begins. So that number right there is this number here. I wouldn't put the SciPens to this. Maybe 10 is its default. But this number right here within the scientific notation is this. So if you want to actually view it, you can change your SciPen, and that'll change when scientific notation begins. I would not, once again, be changing all these things. I'm just doing the extra things to show how things work. That's why coding's awesome, because we can actively control how the scientific notation is written. Oh, no worries. Brendan, you're if you take 474, which, I mean, if you want, I mean, I'm all for it. Like, I want to say, like, I hope people take 474, but I like this kind of stuff. I like being able to manipulate data. It feels like a superpower, because you're like, oh, I can just ask this and this occurs and run this and do this and, you know, whatever I want. I love it. I think question 4 was next. Someone wanted question 4 earlier. And Bern, if you have a 320 question, feel free to ask. Trying out the new stuff in 474 is very good. Just practice up and know what's going on right here. The rank value 1 column keeps track of the product's rank, 578 of 23,000 in the office products. Currently, as you can verify with class, R is treating rank value as a categorical variable, not as a number. Left arrow the contents of the rank value 1 column into a vector called ranks. Where's rank values at? What data frame is that? It's under by. I think it's under by. Rank value 1. These are by 2. Sure. So this is ranks. Oh, it's a large one. That's crazy. Is that the right one? 20,000. No. I think we would buy. This is that the right thing? Because it's longer than I thought. Oh, yeah, no, it should be right, because it's of 20,318 items, and that's the levels. So that's the amount of levels. So if we go here to levels of ranks, and let's go to length of the levels vector. That's interesting. Did it ask us for a subset? Am I taking of the right thing? I'm analytics, so definitely yes. Awesome, amazing work, Brennan, all the time. Keep working. We'll see what answer we get. We'll find out. Hopefully I haven't made a mistake here. Hopefully when I change the assignment, I don't make errors in it. Then run head and tail the levels vector of ranks to spot the 2 ways that the missing values are encoded. Rename both of these levels to NA, no quotes, to delete them. Okay. So we want to go to the levels vector of ranks. So levels of ranks. And we want to go to head of it. There we go. We'll append to this tail. And there we go. What are the 2 ways NAs is coded? What are the 2 ways NAs are coded in this data frame? What are the 2 ways NA is coded? What are the 2 ways NA are coded? I need help. I am stuck. I do not know. We need those 2 ways. And then we need to go to the levels vector and rename them. There's a few ways to do this, but there's a really smart way. Like, I'm going to do it this way. I'm going to call yes. So you got it. I like the and right there. Caroline, 20 points. I'm going to call these bad levels. So in bad levels, we're going to call this. And we're going to call this. And here's the bad levels. And then we're going to go to the levels vector. levels of ranks, and we're going to see if the ranks are contained in bad levels. And that'll tell us trues and falses. And then we only want to go to these positions. Now, this should work. You could put a witch on this. Like, you could do witch as, like, the first and the last one. So that does that. That's fine. And I'm going to do it this way. I think this will work. I like this way. I don't know. And then we'll go here. And then we want to go to the levels vector again. This is the confusing thing, is we're going inside the levels vector and only going to these positions. You want to overwrite those positions with NAs. And this is the safe way of doing it right here. And this is in the notes. It's how to, like, find things and recode them. And you don't need the witch here, I'm pretty certain. We can double check right here. You can see they are removed. And they're just NA. So we removed them out. And where's it reporting the NAs right now? Let's go here to summary of levels, or summary of ranks. And there's the NAs. There we go. That's what we did. And those are no longer levels. We just turned them into NAs. Everything in those positions are now NAs, and the summary confirms it. It's a rather long summary, but we have confirmed that everything there has become NAs. So we overwrote what was in that level position as NAs. So does this make sense to everybody right here that I wrote them as bad levels. You could have just put this right here, but if you have more levels, it makes sense to do this. And you want to find the levels of ranks that are contained in this, go to those positions of where they're at, and so that's why you're going to the positions inside of this and overwriting them with NA. So that's a pretty confusing big code right there, and probably the best way to write it's this way right here. Well, that's got that. We've already done, this is due tomorrow night, and what do you think we've done, like 30, 40% of this? I would say we've done 30, 40% of this assignment, and this is due tomorrow night. So we're rolling. Brendan, do you have any 320 questions? Yours is due tonight. So, and at 474, if you have questions, I'll maybe do one, or I can do a few more, obviously. But anything you're stuck on, feel free to ask. We've already put a lot of this in this video, so this cuts out a good bit of work for people who are stuck. And try to watch along, follow along. When I pause, try to answer the question yourself. That's how you really push your mind. And then hit play when you're like, I got no idea. Awesome. Kelsey, great job. Yeah. It's just doing it in parts. Whenever you see a longer question, just do what it asks first. Like you see, like, run head and tail on the vector. So that's what I did right here. I ran head and tail. And then I identified first. So here we'll rerun it. I identified first that we have this and this. And I ran it on one line because I was like, okay, I'll just put this all on one line so I can run it as one line. That just puts two lines of codes together. So, and I put a space between it just because I'll read through spaces. So this runs and tells me where the offending levels are at, or because it kind of gives a hint. It was like, hey, maybe run head and tail of the levels vector. And we can see here the quote, and or just the blank quote. And then we have this right here. So we then wrote this right here. Now there's other ways to do it, which I would not suggest. But we named the levels, and we named this, and we named this. So we got the names of the levels right there. And the names of the levels vector. 3C and 3D, you got it, you bet. Oh, thank you for putting 474, that really helps. Okay, what does 3C say? Oh my gosh, what do we got to do here? Okay, I don't think it's a contingent question, so we can do this. Oh no, wait a minute, we might have to do earlier ones. Oh, we define prices fixed. Okay, so we're going to fix some prices right here. This is like validating data. So price is fixed to be the vector of values contained in this. Okay, so how are we going to write this? Here, I'll drop some things in the chat right here. So how will we write this? How will we write this? This is the first thing it asks me to do. So how will I write this code? Who can put the code in the chat to do this? So it says define this to be the vector of this. First thing we got to do. Just when you hear that, you'd be like, okay, first thing I'm going to do. You could even put it, you could put it right here. You say vector creation. You could go 3C vector creation. And that's going to be where you can like scroll through and you can see we have, oh wait, that's 3B, 3C. There we go. So Q3C. So Q3C. Q3C vector creation, lowercase c. And you can use these as bookmarks right here to see, like, here's where I created my vector. So what code will I write right here with using those things to create my vector? First thing we want to do. And this will help us stay organized. You can, I mean, don't like remove things, but you can, add things. Madeline, amazing work. Madeline, you're at the 300. Boom, great job. And also Caroline and Kelsey And Brennan and Vedrana, you guys are all at the 300. You're still here. You're still talking. You're still working. I like it. So crazy wacky Wednesday points. You guys got the extreme wacky Wednesday points. So you guys maxed out at the extreme 300. I don't know. Only a few people get these things on random days. So you never know. Like the crazy awesome points. So we've got here, I know, Brennan. And thank you so much for like hanging out, asking questions, because the more you practice, you'll get to 474 and you'll be like, I got this. I miss 474 being taught right after 320 in the summer. I just, next summer session, I'm moving. So I'm going to spend it moving, living with my fiance, and just, I don't know, enjoying life. I haven't had a month off it's not like I don't want to teach, but I haven't had a month off in like 5 years, I'd say. I used to not teach mini-term, but I like mini-term a lot. Like mini-term might be, not that you guys aren't my favorite, but mini-term might be my favorite. It's so quick. You blink and it's over. And it's so crazy because people are very focused. So stay focused in this. And so, yeah, I agree, Madeline. Like I get like 3 weeks off for Christmas. Like we get the same Christmas, but I haven't had like a full month off, I'd say. But even then I'll be like preparing for school. So, I love teaching, and that's my problem is I love teaching so much that I'll be like, I need to make some videos during this time off. But so I'm just going to try to work out, enjoy life with my fiance, and just, awesome. Yeah, that's awesome, Brennan, right there. Yeah, it's like you should just take some time for yourself and relax. And I'm trying to remind myself of that. And yeah. No, she doesn't coach. She's a veterinarian. But I've helped her with statistics and stuff like that. And if she ever got into statistics or coding, she'd be better than me. She's so smart. She's like, I always tell her, I'm like, she has this like superpower that like whenever she tries to learn something, she can learn it like faster. I've noticed in other people. I mean, of course I'm going to say that because she's so awesome. I mean, I love her so much, but I really mean it. She learns faster and she learns at a higher level. And even the smallest things, like maybe it's like making an omelet or something, like her ability to like learn it and take in the information, or like just everything I've seen her learn is like she'll get to such a high level where I'm just like, and I think it's that maybe both she and I are kind of like perfectionists to some degree, and we're always like critiquing what we do. And so maybe that's one of the things I value. Yeah, it's like, I'm just like, yeah. And then you look at other things, like she's doing her residency in anesthesia. And so when it comes to that, like when you talk about like her professional career, like she's very exact in everything she does. And she reads the technical literature, and she, so if she were to start learning if she were to start to learn how to code, she would start reading. She would be telling me everything. Like I've been coding consistently for like 5 or 6 years. I've been coding like consistently. I started coding way earlier in life, but not like consistently. But if she started learning how to code in like a year or two, she'd be like, maybe after a few months, she'd be telling me things. I'm like, how do you know this already? And she'd be like, well, I just read this book on this, and I was looking at this article and this thing that said this. And I'd be like, oh my gosh, you already know it better than me. I love you so much. No, it's so awesome. I don't know. It makes me smile. Sorry, I'll stop. It just makes me smile. Like, I really value like education, and this is my last little rant about this. I value education, and I think we should always try to grow. We should learn and grow together. And like, she's not graded anymore. She's not graded on what she knows. It's her career, and so it's important to her to know these things, and to be able to like, people to trust her because she's very knowledgeable. And so she continues to learn because she has to stay at the top of her field. And so it's not about getting a grade. It's about being really good at what you do. And she is. Everything she's tried, she's like, I'm going to be a veterinarian. Awesome. Everything. Replace all values in prices fixed that are greater one with 100 with an A. Okay, logical check. Logical check. I might. If she ever, yeah. Feel like she and my wife should get out together. My wife is getting ready to go to med school next year. It's unreal. Yeah, that's awesome, Brennan. Congratulations, Brennan. And congratulations to your wife. That's awesome. And like, finding the person you love is great. because it's all about just like supporting each other, and med school is a big thing, like any sort of graduate school or any just school in general. But graduate schools, I'm not trying to belittle any school, but medical school, graduate school, law school, you name it. And so it's a lot of work. And so supporting each other, very, very big. So that's what I'll be doing for the first month is like, I'll make the omelets. I mean, but she makes them better. That's the problem. I mean, I can make other stuff. I'm good at pancakes. I make really good pancakes. So we've done that. We've made like pancakes. Well, if we're making omelets, we're not making pancakes. So, yeah, I know for my 5.5-year degree was a lot of work for me. So, but business analytics undergrad is good. Business analytics is a good degree. It's a good, strong degree, I think. So not just because I teach in it, just because I look at our statistics, we're at the top of salaries for Haslam College of Business. We're at the top of employment for Haslam College of Business, and Haslam College of Business, every degree is doing great. So, you need to look at, one, do you like what you do? And two, can you get a job in what you do? There has to be both. You have to be able to get a job in it, and you have to like it. Hopefully you'll love it. Like, hopefully you love what you do, and there has to be the job though. Like, I mean, I guess if you don't need a job, then you could do tons of schooling and not worry about the job part of it. But in general, most people are going to need the two combo of how much you like it and how much your job opportunity are in that field. And then you've made a good kind of investment in your future. So I need the logical check here. Oh, we got this. You guys know this. I just want prices fixed that are greater than this. Let's swear. And so what do I type? Just tell me the logical sign and I'll put the rest. Here, wait. Just tell me the logical sign. It says that are 100 or greater than. That'll only find the 100s. That'll only find the ones that are 100s. Unknown. Not answering that. Unknown. Just unknown. Not answering you. 30% power. Gotta plug that up. So close, Madeline. You're so close. Yes, Caroline. Nice job. Okay. There, we got that. Cool. We see some trues in here eventually. Maybe. Somewhere. There's a lot of NAs. A lot of no prices. Yep. Greater than or equal to. And then, great job, Madeline. And now I want to go to those positions. How do I go to those positions? I want to go to those positions. How do I say we want to go to these positions right here? How do we go to those positions? I think this will work. I don't want to do it the short way today. How do I go to those positions? You can put in the very, very short thing. Basically, square brackets. And then we want to go to the positions in here. So it's returning the NAs, which I'm a little worried about. Let me do this. Let me put it inside of a which right here. And this should... Oh, there's only one price. Cool. The which returned the positions of the trues. So when I put a which around this, it only returns the position of the true, and we're only going to position 989, and then we're going to overwrite what is in position 989 with what? Boom. Right there. So what you should know about this, these are notebooks. This is a notebook that sold for $989. Is it a gold-plated notebook? Well, investigating the data set a little bit might clue us in on this. We're going to go to buy 2, was it? I think it doesn't matter which one we go to. We're going to go to buy 2, and we're going to go to rows. This is the row right here. And we're going to go around it and go to rows this and this here. So when you look at this, we'll open it as data frame. Let's take a look at this. What do you think happened here? And actually, the question doesn't say to do this, but I would probably prefer to do something else. These are the bidding prices on Amazon's for notebooks. What do you think happened here? Can you see it? Look at the price, and then look at the notebooks around it. This is a notebook. Remember, this is a Avery durable view binder with 2 slant ring, holds 8.5 something. We don't know what it holds. That's a mystery. Holds 8.5 inch, 11 inch, paper, black, 1 binder, and yeah, exactly. This right here should have been this price right here. So they this is an error. And now I'm not saying to do this, but if I was handling this data set, I'd probably just recode it as 989. I think there's good evidence to suggest right here that they actually meant to put in $9.89. Does that make sense? The question does not say to do that. The question says to go in here and to overwrite it with NA. So now if we go and look at it, we got to redo the thing here. If you look at it now, did I not redo that? Try it again. Double check. Oh, I did it in prices fixed. I'm doing it in prices fixed. So prices fixed that's become an NA. So if we go to the position, this right here, and prices fixed, sorry, I didn't do it in the data frame. Now it's NA. And you can see the prices around it, because these are the other prices, are the following. So now we're only looking at the prices vector because we saved the prices vector. And I overwrote this position here, which was in the original data frame, this right here, but we just took the vector of it. That's what I was like, wait a minute. I'm not writing to the data frame. I'm writing to a vector we saved outside the data frame. So we saved the vector outside the data frame, and then we overwrote to the vector position. You could do it. You could do it to the data frame. It's going to be very similar code. Oops. If you wanted to do it to the data frame, which don't put this in here, the data frame is called prices. It's called buy. There it is, buy. I was like, what is it? We want to go to buy to $ price. And yeah, there we go. And then we're going to I could do it to the vector inside of here. Cool. And that should change in the data frame. So that changes in the data frame. So now, did I lose my data frame function? Here it is right here. So when we do this here and we make this, now it's NA. So now I've overwritten it. This code right here overwrote in the data frame. It went to the vector in the data frame, but problem is too, we just changed our data frame now. I mean, we might have the Excel file. It's like, do you really want to be changing your data frame, or do you want to work as like store a copy of the vector and work with the vector and clean the vector? Preferences. It all depends, but now I've overwritten the value in the data frame. Does everyone understand this small difference right here, that I've now overwritten the data frame, and I took a subset just so we could view these rows? Like, you'd be like, well, why did you take this subset right here of rows from your data frame? It was just to see it. Just to see the change we made, where this now is NA from this line of code, changed this to NA. And it would change anything greater than 100. And I shouldn't do it. I was going to do something really crazy. But I was going to change everything greater than 9 to 100 to NA. If I just do like greater than or equal to 9, all these will become NA also. But it would show what happens, but there's no undo button in R, and I don't want to do that. I could relive the data frame, though. Replace all NAs with the median. Okay. If we're going to replace all NAs with the median, what's the first thing we want to find? So Q3C. If we want to replace all NAs with the median, what's the first thing we want to find? So here's a hint. If we want to replace all NAs with the median, what's the first thing we want to find? So if we want to replace it with the median, what's the first thing we want to find? So remember, we want to replace all the NAs with the median. So you should think, well, yep, the median. Cool. Will this work? Yes or no? Yes or no, will this work? The answer is, and I'll say this one, I'll give you guys this one. The answer is no, because there's NAs. This will not work. We have to do NA.remove equals true, and there's the median. So you know what we could do? We call this med for median right there. So now we've got our median saved. So we've just found the median. The next thing we need to find are the positions of the whats. The next thing we need to find are the positions of the whats. So the next thing we'll have to find are our positions of our whats. Oh, wait, is it, Madeline, I might have missed that. I don't know if you're asking a question, or maybe you're answering this one too. Yep, the NAs, yep. So let's go here and type NAs. NAs there. So we got NAs. And with NAs right there, we're going to find the positions of the NAs. So we're going to use a function is.na, and we're going to go to prices fixed. And actually, this is where the NAs are at. It's a vector of true falses. And this will tell us where the NAs are at. If you really want, you can put a which around it to turn it into actual numbers. I believe it'll work either way, though. And now the NAs are the positions of the NAs. All of these numbers represent where NAs are at. we should see NAs at the very start of our data frame. So if we go to buy 2, and in price, what do you notice? A ton of NAs at the start. That is what's represented right here with all of this. And we don't see if there's anything in here until, wow. Wow. There's never anything. Oh, wait, we're in the thousands. But it will do the max print before we get to that. There we go. 977 is here. So if we get down to here, I should have just looked at this. So it's 700 or so we're seeing stuff appear. Or 600s. We don't have stuff we have stuff in the 600s. So we go here to the 600s, we'll see data there. So in the 600s, we see data. And then as soon as we get to 639 is also missing. So 639. 639. There it is, 639. And how do I know 639 is missing? Because of this right here. Does that make sense? Is prices fixed a function was missed earlier? It's a vector created. You have to create the vector. Here we go, Vidrana. The prices fixed vector is created right here. It's an object in the global environment. It's a vector saved, stored as by $price. So by $price is stored from the data frame into a vector, price is fixed. And now that's an object in the global environment, a vector in the global environment. Does that make sense? I think we got it right there. So, and now we have our NAs. We have the positions of our NAs. So what do we want to do? We want to go to prices. Who can put this code together? So here's what you want to do. I'm going to give you the components. You ready? Here's your components. And I want you to try to figure out how to write this code. So there's the components in the chat right now. I'll put them here on the screen too. Maybe a different order. So I need to take these components. So NAs, my left arrow, try to figure out how to write this code. Yeah, I think this will work. I think I have everything I need. I'm like having to write the code in my head as I do it. And is that there's 5 things on the screen? So use all these components right here. Think about what you're doing and use those components. And I hope this helps. I'm trying to do it more like a create your own adventure, choose your own adventure thing. Like definitely if you're watching this future, pause the video, try to write it yourself. It'll make your brain start to be like, gotta put in the orders, gotta do it. I'm trying to make these videos as useful as I can in the future. I know some people might just look at the answer, not the end of the world, but a tropical storm. So much crazy. Close, that'll overwrite the things in NA with, so that would overwrite, so you're close, but then that'll use that. Remember, when we use square brackets, that needs to be connected to an object. Let me see here. Close, Brennan, you're so close. You're so close. Here's a hint. You ready? That's your hint. Oh shit, I keep touching the mic. This is your hint right here. This is your hint. You're so close. I noticed there were flight bans. The first news is tropical storm makes landfall. And then the second news is bans from flights. And I'm just like, what's going on here in the world? Like, why is there? Why? I mean, I don't understand a lot. It's personal opinions with Brian. You know, like, there's a lot of things we need to fix in America right now. It's personal opinions. Personal opinion. It's just and we as a university are working towards, as much equality as we can. Like, you never have enough equality with how people are treated within a system. And that, I think, is the biggest thing, is that, that's what I try to do. And that's my goal, is that everyone knows that you're all my students. And, it's just, I don't know. I can't. So I understand all the angers and frustrations. I mean, not personally, because it's not something I experience. But I don't know. I can't empathize, but I can sympathize. So it's really tough, and that's why I say things like like vols help vols, because I really believe we should be out here to help each other, and I don't like seeing people hurting each other. I'm not like I don't like seeing policies that hurt people. Like I don't like seeing Anyways, enough. That's just my personal feelings, and people are allowed to disagree with whatever way they want. So yeah, this is once again personal feelings. It's really hard to talk about, like, we have to win over hearts and minds of people to have them understand, our viewpoints. And that's why I listen to people. I think one of the best things I can do a lot of times is listen. So, and that's usually not like as an instructor, I talk a lot, but as a person, I listen a lot. Because my job when I'm teaching is to talk, but my job when I'm a person, not that I have a job as a person, but I feel when I need to understand what people are going through is to listen. I mean, if anyone has anything to share now, you're free to. This is office hours. It's just, but I think when people are communicating to me what they've experienced in the world, my job is to listen and understand, because I only know the world through my eyes. And my job is to then learn as much as I can from them communicating with me, and to have these people in my life, to have people from all different backgrounds, because I'm completely biased to what I know. Like I only know things through my eyes. And then I remember that at a lot of times. So that's just what I've learned over life, is that it's really hard to be unbiased. And so we have to rely on everyone in our community. And when I say vol means, everybody, like I mean it, like, no matter what your background is, I want us to all support each other. And I know, my stepaunt had terminal. I'm so sorry to hear that, Andrew. I'm so sorry to hear that. I hope you're doing all right. And I know I'm so sorry. Like, yeah, Murray said earlier, you're doing terrible. I'm so sorry to hear that, man. If you guys want to throw some hearts in the chat for Andrew, Andrew, we got custom emojis here, but man, we're throwing some hearts. I'm throwing some hearts in the chat for you, Andrew, man, because I'm so sorry. That's really tough. And, like, I think the best thing to do is just to, to like support each other. And I think what makes it's really hard for me is like, I want to see everybody, like, I don't know. I don't want to, like, it's tough. And I don't know. I understand a lot of the pain out there, because it's personal opinions, because I don't know it personally, but I understand. And so I don't know. Okay, you guys ready? It's just, man. Let's store right here. We're back on track. So we're going to go to those positions of those NAs. We're going to store right here. Oh, we got it. Look at that. Got it. That was personal opinions right there. And everyone is free to their own opinions. Look at this. We've stored it right here. And yeah, if I can leave you with one bit of advice, it's like, get to know people. Oh, sure. Yeah, we'll hop over to that in a second. If I can leave you one bit of advice, is like, get to know people and broaden. I mean, like, I'm just glad that I've had so many people in my life who have brought me understandings of what they go through. I mean, I'm never going to know it personally, but, talking to people, getting to know them is your best. Oh, thank you. I just want to make sure everyone knows I'm coming from a place of caring. Thank you so much. Like, thank you for your appreciation. And, I don't talk about these things during class, because I try to stay focused. I stay as focused as I can be. So expand your world, get to know people, and the world gets a little bit smaller. And you realize that, I've met so many amazing people. And let's do the assignment right here. Is it? Yes, I found it. I found it. I found it. Yeah, never stop learning. Never stop learning about this world and people. And that's, you know, what matters is like growing as a person. And yeah. That's it. Yeah. To see. Let's do it. Consider a sequence that starts. Oh, we got this. We got this. Brennan, you know what? Because here's the thing. We're going to figure this out. You ready? We're going to get some 474 help. So what are some of the arguments inside of sequence? You know, we can cheat to find them. We can cheat to find them out right here. We can go to SEQ. And let's take a look at SEQ. And let's take a look at them. We've got this right here. We've got some of the arguments. I see an argument here. Am I blocking them? I see an argument here. I see an argument here. I see an argument here which can be called length. It can be just called length. It does what's called a partial match on it. So it says we want a sequence that starts at this. What argument does that sound like? It's going to start at this. Oh, wait, we want this one. We want a sequence that starts at this, ends at this, and it wants elements of this. Now, ignore this last part. Ignore that for the moment. But what do we want right here? What do we want? Yes, Tosh, you're right. And we're going to go sequence from equals 5 to equals 8. And then we've got here, Brennan, wait. Was it? Did you just figure it out? So we got here from, and then we have length equals 321. Maybe that was it. But now we're just going to go this and toss it on right here. And it wants how many? So wait a minute. This gives us all trues and falses. How can we count up all the trues? What can I put around this to count up all the trues? What can I put around this to count up all the trues? What could I put around this to count up all those trues right there? What could I put around that to count up all the trues? Close, 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 close. You can do a which, but which will tell you the positions of the trues. Which will tell you the positions of the trues. Which will tell you the position of the trues. Which will tell you the position of the trues. So instead of which, so close, not which. Another way that can add up all the truths. Think when I say add up all the truths, another letter word, another 3-letter word that's basically like adding up all the truths. Another 3-letter word that is adding up all the truths. Another 3-letter word that'll add up all the truths. Another 3-letter word that'll add up all the truths. Go in front of it. I can do something. Which will find the positions. So there's the positions of the truths, which we could. There's a way to do it with which. Oh no! Here's the first letter of it. Here's the first letter of it. 3-letter word. 3-letter word that'll add them up. 3-letter word that'll add them up. Three-letter word that'll add them up. 3-letter word that'll add them up. I want you to see it in the know and be like, oh, yes, that'll add up trues. Because trues are just ones and zeros. You got it. I know you know it now. Start going through the letters. Be like, sub. Be like, no, wait, no, not sub, not sub. There you go. Nice. You guys got it. Yep. There we go. There we go. There we go. Do you like SUA, SUB, SUC? No, I know when you see it, you're like, oh, that's it. It'll add it up. We could find the percent of trues with this right here. That finds the percent of trues. And you got me doing it now. And here we go to sum, which is the amount of trues. So that's how many trues there are. So I'll do how many trues. Another question on 320 or 474. What does everyone have today for 320 or 474? What does everyone have today for 320 or 474? What does everyone have today for 320 or 474? You're welcome. Anytime, Brennan. Anytime. No, like once you see it, it's like, I was so close. Unfortunately, a lot of people will do something like this. I've seen this before where people do this, and now they're getting all the positions and adding up all the positions. So this was all the positions added up, which we don't want to do. You could, it's a very long way of doing it. I would not do this, but it works. You could do this right here, and you could divide by 321, right? So you could divide by 321. Wait, that'll get you the percent. No, what have I done? Well, which is how many? Oh, and then we get the length of the which. Oh, yes, yeah, so you could do that. You could do which and length of the which. So the length of the which, and then that gets you that, and then you could divide by 321, and that'll get you that. But this is way too much work right here. You don't want to do this. You want to do, not insert. Not insert. You want to do some. Much quicker to do that. Same code. The shorter you can write the code, usually the better. We've got an extra parentheses around it. And okay, good. You're welcome. So any last few questions right here? It's about time. Charge my phone and run some errands today. Any last few questions right here? I think that does it. We've done a lot of work today. We did a lot of 474. I would say we did like 40% of 474 assignments. So if you're working on 474, a lot of what we covered in lecture, I think we're way ahead of schedule. So it's a really good pace that we're at right now because the assignment for tomorrow night, is anyone 474 still watching right now and maybe feels really good about the assignment? Like who's watching 474 right now and feels pretty good about the assignment? Like, yeah, I got this. I've got 36 hours to turn this in. Awesome, Toss and Sarah. Great job. Yeah, if you notice, we've been covering it in class. We're going to go over the A rules a little bit more tomorrow. And yeah, so it should do it. You know what I'm going to end with? Just got a few more minutes left. I'm really dismayed that my attempt to make it work didn't work. And then I'm going to make this work right here. So here's the make function. Can I reverse time on this completely? We're going way back in time right here. How far back in time can I go? We're going back to the beginning. I love time travel. Look at the time travel. We did so much work. And let's go down here. And here's where we are doing, and is it only reporting? So here's the work we did where it was reporting it's going to take data and turn it into V. This is where this begins. And then we don't need the item frequency because that's good. It's fine. We could use that. We're going to go here, put this inside of here, and then this should just take data, which will augment to it. So this will be called make rules. And that works there. And then we should have a function called make rules now. And make rules should work on a data frame. And do I have survey 11 loaded up? I do. And it's not printing to the screen, which is the issue. It's because I think it does a cat. Like when it prints the rules it prints, and we could confirm that it's working by simply going here and putting in survey 11 right here. Like no object data found. Wait a minute. Okay, there. Let's move this around it. We've already got it stored in the global environment. We're good. So that should store this to this. No object data found. Where's data being called? Oh. Oh, is that it? V. Function data. Oh. I'll see everyone later. I'll get this fixed up. I'll talk to you guys later. Bye.